I started thinking about that the little movement vectors are not really movement vectors at all. They're just a feature. It's just saying like nature said, here's a feature. It's instead of just saying it's an edge that had moved in this direction to get here. But there's no sort of beyond that. There's no internal knowledge that this is movement. It's just like a static feature. Like at this point in time, there was an edge moving this way. Not that there's going to be treated differently than the color columns. That was the idea. I like that idea. But now we're recording, so.
Yeah, do you want to start with?
No, we can start with the review. I don't care. Whatever you want to do.
Yeah.
Up to you guys.
Yeah, I feel like that already kind of ties a bit into the review, like.
Well, that's new stuff.
So, yeah.
I can just draw a picture of that if that wasn't clear, or you want to just.
Yeah, do you want to?
Maybe just at least a big concept. Sorry, I can't be more helpful here, but just of the.
You want me to do a review of the whole thing? I thought someone else was going to do that. I said, oh, I thought someone was going to do the review, and I just was sitting here and listening. Okay, here's a review of what we were working on. Up to this point in time in our story, we have a theory and biological theory and an implementation of learning and inferring the structure of physical objects, you know, and I'll just back that physical objects, and so that's been working pretty well. We can do that with remote sensors or non-remote sensors, and then we've been working on how do we handle when the world is changing, the structure of objects changing, and so we're still thinking about like, okay, things that are not like mushy things like t-shirts, but like a stapler opening and closing, or traffic lights changing, and so on. So we wanted to add ability to learn a model of behaviors, and the idea that this would be in addition to the model of the structure of physical objects, a column could learn the behaviors of those objects. And then we wanted to apply those behaviors to other things. So we had to figure out how to learn the different morphologies and the changes of an object. And so we first started out with the idea there might be some sort of single state variable that represented the state of like the stapler. Then we said, no, that's not going to work because the states of objects are very complex and the multiple states at once and multiple behaviors can be happening. Then we said, oh, maybe we could do we could learn the behavior or the state at any individual at different points on the object. So instead of having a single variable that represents the state of the stapler, which once more we could then do something like we did with compositional objects and say, oh, maybe on a point by point basis. That made a lot of sense, but it didn't work like originally we said, oh, maybe just like the compositional objects. And there's a hierarchy or something like that, and that didn't work. So then we ended up with an idea which is fairly complicated but very elegant, which is that there are in a column. We've always said, here's the summary in a column. We've always said, okay, here's a column. We've always said, okay, there's a reference frame which has a location, and that's in layer 6, and then there's a feature coming in to layer 4, and there's a connection between these. So we pair the feature with the location, and that's how we learn the structure of the object. And then we said, what if we did the following? We said there were actually two locations. There was 2 reference frames, and there was sort of 2 models at once in a column. Sorry, I should use erasers. And if I'm not explaining this clearly, you just jump right in and make it more clear, because I wasn't prepared for this morning. So there's 2 models here. The one we've already talked about, which is sort of static features at locations. And then the other one would be, instead of representing static features at some location, we represent when things changed at one location. So this is a change, meaning we only store something in this model when something has changed. So the other one is only store things when it's static, and the other one is changed. In vision, you might think of this as this would be the parvocellular pathway, this would be the magnocellular pathway. These are bits that only become on when there's something not moving. These bits only become on when they're moving, something's changing. And so we have two reference frames now. Why do we have two reference frames? Is because we're going to learn models of the change or the behavior. This is a behavioral model. And this is a sort of physical.
Morphology.
Well, morphology is a little bit, we'll call it morphology, but we're still struggling how to do more than morphology. Like color and things like that. Anyway, we have a behavior model and a morphology model, and they're both being learned at the same time. So the sensor's moving through space, they're both moving through locations in space. But when something changes, we enter, that's an event up here, but when something is static, we enter it here. It's exact same mechanism, they're tracking the same way. The difference though is that these two models, even though they have two reference frames, they anchor separately. So what that means is we think about anchoring represents an object, right? So our old way would anchor on the object and say, okay, this is a coffee cup or this is the stapler. This new model basically says I'm anchoring on the behavior. And so it's only the parts, I'm going to represent all the things that are changing in this reference frame. And the advantage, even though they're co-learned, the advantage is in the future, in another situation, I can observe changes and recognize the behavior. And independently of the new object. So I can take a behavior I've learned from one object, and now I can observe it on some portion of another object and infer that behavior. And so I say, oh yeah, this other object is doing the same behavior as something I've learned before. So they co-learn on one object, and then but they're separate because they anchor separately. That's really the issue. And so, and you can think about this change model, it may only be occurring on some subset of the main model. So if I have a bigger object like a traffic light, well, the only parts that are changing are the three lights. And so the model of the behavior of the traffic light only involves those three locations. It doesn't involve anything else. It doesn't know about any other morphology about it. It's just that I see three things changing, and I can place them on top of a traffic light, or I can place them in some new environment in some other way. So this idea that there's two of these things working to learn together, two different models, and that then they can be separated out, was a really great idea. And we've speculated something like this might be occurring in the past. Just the physiology and the anatomy of the cortical column suggests this, but I never really understood why it would be like that. So this idea here is we have these two models going together, and that was, I would say, is a summary of the major accomplishment we had last week.
And I guess one more detail is that there's the timing.
I forgot, yes, as soon as you said there's one more detail, I said, oh yes, I forgot the one more detail. There is time, and I've always speculated, and we'll just write time up here, that I've always said time is a signal we need for sequences, and I've written and speculated and hypothesized that the time signal comes from the matrix cells of the thalamus, and it's projected broadly across the cortex onto layer 1, and it presents a time signal so that you can learn the timing of sequences. And so the change model often, it always involves time. At least there's one change in time, but it might be multiple steps. So when a stapler is opening, there's a whole sequence of changes in the location space of the stapler as it's opening or closing. And or the traffic light, the lights go in a sequence of certain timing. So the way to think about this model of behaviors, the behavioral model, is it's really like a four-dimensional model. It's a model of space as it's changing through time. Whereas there really is no concept of time in the morphology model. Morphology model, here's a set of features that are static in time, and then the behavioral model says, well, these are a set of changes that at this point there's this set of changes, and the next moment of time there's this set of changes, the next moment of time there's this set of changes. And this combination by adding time and this representing it as like this four-dimensional model of behaviors allows you to learn any behavior at all possible, really. If you think about it, anything that can be represented, any combination of changing features in space can be represented this way in any order.
Do we think that a melody would be represented as because it has time, would it be represented as a behavior or?
Yeah, well, we were speculating just the end of the day yesterday. I want to go there because our melody, we've had this idea of a melody. That was the very first thing we did in terms of really neural mechanisms, how to learn sequences. And that's the temporal memory algorithm, and it was the Dermot paper. That was like, what, 10 years ago or something like that. Maybe longer, I don't know, but anyway, 10 years ago. And one of the things, I'm assuming everyone knows that. So you got the layer cells, it's forming these SDRs and it's learning a sequence. The problem with the melody one was it was never dealt with the fact that the invariance of pitch. It basically would learn a melody in one key and it wouldn't be able to recognize it in a different key. And so this has always been very bothersome. And so I never really resolved it. Vivian wasn't too worried about it. She kept saying, oh, we'll just figure out the intervals, something like that. I don't want to dismiss your comments. But then I realized this in some sense, it suggests the solution to the melody problem. Because you learn the melody in a particular key, but the melody is basically a series of sort of snapshots, but it's the change that really matters. The melody is almost all behavior. So you learn this behavioral model, even though it was aligned in one particular key, then you can play the behavioral model back, which is the melody, in a different key. And this works, I realize this works because music is represented as, the notes are on like a log scale, right? It's always like a doubling. And so you can basically shift the melody someplace else in the range of frequencies, and it works. So this suggests a solution to the melody invariance problem, which I never ever had. But I realized there were still issues with this. There are lots of issues with this basic idea. We haven't worked out all the details, but it's such a nice idea that it makes us feel like it's likely correct. And lots to suggest it. So I would say it's really, really likely this basic idea is correct, even if we don't understand all the details of it yet. So that's a summary of what we agreed to, I think. It's not a summary of the things we were still struggling with.
So the magnicellular cells, these are going only to V1, or are they also going?
No,
to
I'm just pointing out that I'm pointing out that from the retina, there's two basic types of input to the cortex. I'm just saying and they're center surround cells. The parvocellular cells are center surround. They only become active when something stops moving, like it's stationary. And the magnocellular cells are center surround, which only become active when they're changing. And so basically they just represent change and static, regardless of what you want to call them, whether they're color or anything, doesn't really matter. It's just on the retina, something has changed at this location or something has stopped changing and is static at the location. And so that basically, it's not even, the idea of movement or edges is determined in the cortex. You know, what features that becomes in these mini columns is determined in the cortical column itself. So the basic idea is that anything that's changing in this, we could be modeling anything here. Anything that's changing is represented here, anything that's static representing here. And I only use the parvocellular and magnocellular to point out that that's exactly what we see from the retina. Yeah. And we've been using that anyway. We've been using the magnocellular cells for representing movement of the sensor, but this is now representing movement of the object. Remember that the upper columns have the cells are responsive to movement. Yeah. Most of the cells that people are able to identify in a cortical column, even in V1, are responding to movement of some sort. But the upper ones are responding to movements of small objects. That would be movement relative to the object, and then down here the movement would be relative, the eye movement relative to the world. So
and in the higher regions, there will also be movements of parent objects.
I didn't say anything about hierarchy. I didn't say anything about parent region.
I'm trying to visualize what that change would look like in the higher.
Okay,
region.
well, we could go there. I think last week we basically just were focusing on a single column for the most part, and the idea that there's these two models in there, a behavioral model and a non-behavioral model. And we call it morphology, but because it could be applied to concepts anywhere else in the world. I think the right way to think about it is here's a model of things that aren't changing at the moment. There's a static arrangement of things. And then there's a model of here's things that are changing, and they kind of overlaid one another. And so we can call it a morphology model, but that sort of implies I'm looking at physical objects, whereas it may not be physical objects. We also talked about, for example, some of the columns could be color columns. And they could either be like a mini column, we were talking about the blobs in V1. So some of the mini columns would represent color, that's not really morphology. It's sort of, it says, oh, there's color at this location. Or you could say, oh, no, there's a new color at this location, it changed to, it was, something, now it's green. So I think the word morphology helps us think about it from a low-level sensory, like a primary sensory cortex. But I think the real way to think about it is it's static and changing. That's the more generic way to think about it. And then we were struggling with lots of issues. We could talk about the issues we're struggling with. I thought this is a summary of what we did do. Did I miss anything else?
No, yeah. And I think it's a really beautiful solution because it takes the mechanism that we already had and it basically does a little tweak. Instead of storing features, we store changes
Right.
at locations. And it solves the issue of being able to apply any behavior to any object without having to see it before.
It also allows you to learn any type of possible behavior that you can incredibly imagine can be stored in this way.
Yeah.
So it's very, very flexible and you can apply this to anything. Right, so it's really beautiful and the beauty of it makes us feel like it's right, which is a dangerous thing sometimes, but in this case, I think it's a good thing, super elegant. So that's the fun, exciting part of that, and we haven't talked about the challenging, difficult parts. Okay, so there's the summary. I'm done, unless I missed anything else.
Yeah, I guess, Misha, you're the only one who hasn't heard this before. So how does this sound to someone who hasn't been in all the brainstorming meetings the past week?
This sounds great. I'm curious if there are any more details about how change is actually modeled on a lower level.
I didn't understand that question.
How do you model the object changes?
Well, this is the model. The model is it's changes at locations in space, right? There are changes occurring on an object. So the model is a model of changes. It's a reference. It's basically the model is very much like the morphology model. It's the same idea. You can look at different locations on the object, and the change model, the behavioral model, is only going to store points that have changed.
So is it a delta between features?
It's just I think the right way to look at it is just the change, and you don't really know. It doesn't record what it was. It just says this is my thinking now. It's like I'm saying there is now. First of all, we're going to detect the change, and now what I want to store is what is now there. What is now at that location. So, for example, if it changed from red to green, I would just say at 1 second in, a point changed from red to green. I would say at 1 second, this thing changed to green. I don't say it was red. I just says it changed to green. And if I'm looking at if there's an edge that appears into this point, I would say I don't know what it was before, but right now there's an edge here. That got here by moving in this direction, that kind of thing. It's not actually recording any kind of delta at this point. That information could be inferred. You could assume that if it's not changing, it would be the same, right? So if I say that something changed at time 1, if it changed, then whatever it was before was what it was before. So if it changed at time 1 to green and time 2 to yellow, the time 2 I don't record that it was green, but it is green because the last thing it changed, it was green. So, there's constancy in time for that. Right. It's sort of like the same object, but one is masking for changes and one is masking for static features.
Yeah, like I feel a useful visualization is the having the two kind of reference frames above each other, where one is kind of features at locations and one is the kind of changes at locations. Which we've drawn a few times over the.
Yeah, maybe this.
I'm not sure.
I was trying to do it on a virtual whiteboard, but I think it's just more distracting than.
I saw that.
Morphology model, what we already.
Yeah, sorry.
Would have the stapler, which is features at locations. So that would be like all right, we have an edge here and here and here and here, and there might be a color at all of these locations too. And those are the static features. And once the stapler starts moving, you would, like, before the stapler moves, there's nothing actually stored in the behavior model. This is a different reference frame than this one.
But they're co-located.
Yeah, as you're moving your sensor, it moves like at this, like it moves in sync through those two
Yeah,
reference
as
frames.
soon as the top of the stapler starts moving, then the upper model says, hey, things are moving at this location.
Yeah, and then it would lay down, all right, now there's an edge, now here's an edge, now here.
Right.
And then at the next time point, you would say, all right, now the edge is here and here. So,
But yeah, and not just an edge, but an actual moving.
well, I think that this, Niels, this is the thing that I came up with yesterday. I'm gonna try exploring more today. I think it was very intuitive for me and everyone to think of it like, oh, it's a moving edge. And of course, it is a moving edge. But I think the feature, I think the way to think about this, at least I'm gonna push for it for a while until you convince me otherwise. The way to think about it is it's really just a feature, and there's no, the feature itself could encode in it like, oh, I got to this edge by coming from the left or coming from the right or something like that. But that's not what, but there's no, the column doesn't know that. The column just says it is a feature that appeared here. And there's
Interesting,
no,
okay.
no ability.
I mean,
for the
that, isn't
column
that kind of going back to the snapshot view we were kind of discussing last week? Instead
I
of
don't
where you
remember
have
this.
a bunch of more static snapshots over time rather than
But
we have a change at a location.
But this is, we're not talking about the morphology model. We're talking about the behavioral model right now. So.
Okay, but
It's,
I guess what was described there was features at a location at a point in time.
right. So imagine in the stapler example, you could think of that as a series of snapshots, but it's really it's a flow through time, right? There's really the beginning and the end of the sequence, and everything, they have sort of the changes or where it began and where it ended. In between, it's just flow of time. And so I'm not sure it's not really snapshots. In fact, this idea that I just suggested, that the behavioral model only records behaviors and the static model only records things that aren't changing, would imply the following. If I have a stapler and the stapler always moves continuously and then it gets to the top, that would imply that I learn what the stapler looks like when it's closed. I learn what the stapler looks like when it's open because it's stopped at that time. I can look at it. But I actually don't learn what the stapler looks like in between, which is kind of weird. I don't really learn what the stapler looks like in all these in-between positions. It's basically like, looks like this. Now I have then I have this behavioral model that says all these things are moving and now it looks like this. That seems a little weird, but I like it if I can get it to make it work. It's like, I don't really want to.
Is it possible maybe to revisit the issues with the storing feature changes at locations? Because I feel like that's at least until yesterday the view we had, and so that might be both a useful recap and also a segue into
what challenges are you referring to?
Well, that's my question to you, because you said that this, presumably this alternative is to address some issues with that.
Here,
I think it's a very, very small tweak on how we talked about it before.
but it does change the way you think about it.
Yeah, but it's still like.
The small tweak that kind of changes.
Applies that here for the morphology model, many columns would represent like oriented bars or
Edges.
color or, yeah.
Edges.
So like.
Oh, right, they represent the orientation of a feature at this
Yeah.
location.
Yeah, or color.
Well, then we extended it to color, and that's
Yeah.
where the problem started occurring.
Yeah.
Okay.
And then here for the behavior model, what actually comes in, what is being detected from the magnocellular pathway is changes. So there we have a lot of activity if there's a bar moving in a certain direction. So we would have like the mini columns would represent, for instance, movement into one direction. And I think if I understand right, what you're saying is that this column, it doesn't store anything about where it came from and where it moved to. It would just store,
And well, the feature means that, but the column doesn't know anything about it.
yeah,
Here's the problem I saw. We start off by thinking about these moving edges. Oh, that makes a lot of sense. The staple is moving, the morphology is changing, right? So maybe now we know how the edges are moving. Then we added color. We went and looked at the color blobs, and we said, oh, there's these columns that represent color. They don't really have movement. They just either change one way or the other. They can be green or they can be not green. You know, it could change to yellow, it can change, whatever. So there wasn't this concept of movement, wasn't really that. It's something just appeared, right? Or something could just disappear.
yeah, it's basically the mini columns there detect change, and
Right.
represent change.
So then I asked myself, well, would these mini columns be treated differently? Why would the ones that represent moving edges be, we would somehow say, oh, we know that's moving, we can do some sort of path integration or something like that. And the other ones don't represent movement. Well, it's possible. But I said the more generic case would be to think about that the mini column, the feature could be an edge moving this direction, but it really just means there was an edge that was moving in this direction and now it's here. And the cells don't know that. They don't know that this is movement. It's just a thing. I could have done the behavior of just, there's an edge that appeared at this location. And so like it wasn't there before, now it's there. And that would still describe the behavior. But if nature said, hey, let's add the little motion part to it. So this feature is, there's two separate features, an edge at this location that had been going this way, an edge at this location been going this way. There's just two different features. Then it's much easier to infer behaviors. But the neurons aren't taking advantage of the fact that it was moving. It's just dividing up the feature space into more refined features. I don't know how better to say it than that, but the point is that all the mini columns can be treated the same. It's just like an object, this feature appeared at this point in time, or this feature disappeared. There was a feature and it's gone, or there was something, but now something new is there. And I don't need to make a distinction between color and moving edges. The movement will be captured in time.
Yeah, so we don't have to represent like movement in the model itself and then apply the movement to the locations of the morphology model. We just represent right now that feature change, and that's nice because like we can imagine learning a behavior, like you said, where we actually don't have movement. We just press a button and a feature appears over here. It just appears. It doesn't move there, and we can still. You would still store that in the behavior model without detecting.
Right, and then the color example was like that, you know, there was no green dot here, now there is a green dot, you know, didn't move, it just appeared. And so the edges are like that too. I suppose if an edge, I don't know what would happen if an edge just appeared in like instantaneously, something appeared with an edge in it. How would that be represented in the behavioral model? It really couldn't say which direction it was going from. Maybe it would encode both, you know, maybe it'd be two, you know.
Yes, yeah, that would be my next question. If like the direction of movement is encoded by just like the sequence in time, or if we can actually distinguish direction of movement at once.
You and I can distinguish the direction of movement by looking at the cell response, but I would say that the model doesn't know that.
So
The
basically,
model only knows what time tells it.
here we wouldn't store the direction of this. We would just store, all right, at this point in time, a feature appeared here.
Well, no, the behavioral model says the feature itself is an edge that was moving in this direction. I could just call it, imagine when edges moved to the right, they were green, and edges moving to the left, they're red.
Yeah.
It's like saying that. It's like, oh, this is the green edge, this is the red edge.
So it is part of the feature that's being stored.
Yeah, but there's no way to take advantage of it. The neurons don't know how to take advantage of that movement idea. It's just a feature appeared, and it turns
But
out.
they can distinguish the two directions.
Right, but they don't know that it's a direction.
Yeah, it's not like they take it and apply it to the
They
reference.
don't know,
frame or
nobody
something.
knows it's a direction. It's just two
They
different
know
features.
it's different.
They know
whether
it's different.
there's opening or
Right.
closing.
Well, they know, I don't know that yet either. All I know is that I'm gonna say when something appears.
Why
here-
wouldn't they know it's a direction if those mini columns can be sensitive to
Because when
particular
I'm saying they don't
directions of
know it,
movement?
no, there's no mechanism that's taking advantage of that knowledge. There's no mechanism that says, oh, these are moving, let's path integrate in this direction or something like that. it's just a feature.
Yeah, I mean, there's no.
But I guess imagine if you're trying to infer where in the state space you are, it's helpful to know that like, oh, okay, in that part of the state
Right,
space,
it's really
edges were
helpful.
moving in this direction.
Right, it's very, very helpful to differentiate two, it differentiates different behaviors. It's really helpful, but we're not, so we're taking advantage in that regard, just like I could take advantage of color. But there's no one's taking that knowledge that it's moving and doing something with it. It's not like, oh, we're gonna like project where this edge is gonna be next.
Yeah.
Whatever appears next appears next.
Yeah, so we do detect the direction in the mini columns. We can associate the directional change with the location in this reference frame, but it's not like we take the direction, apply it to this.
Right. We're not,
reference frame
it's.
Yeah,
basically-
okay. No, that makes sense, that we're
I
not
was
applying it
thinking
like that.
before, and maybe everyone else was too, I was thinking before, like, oh, these movement vectors, we're gonna use them somehow, we're gonna like path integration forward and predict where things are gonna be based on these movements and how, no, it's basically
Right.
saying, here's a feature, and here's another feature.
Yeah, I think the path integrate stuff, it'd be cool if it worked, but it's just hard to, it feels like if that's ever going to happen, it's going to be a very slow, deliberate process. It's not like,
Right,
yeah.
right, it's hard to even imagine how you'd apply it to all these points and everything.
Right.
What got me to this idea though was just thinking about the color example and saying like, well, why would color be treated differently than edges? And I don't like that. I just feel like I want to be able to put any attributes I want in the mini column and they're all treated the same. You know, it could be some
Could
other
color,
attribute.
I mean, if a color is just changing, like, red to green, is that
No, the
almost
color
like,
is, this is not red to green. This is basically, it's just, now it's green. It's not like I
right, okay,
don't,
but I guess I'm just wondering, is that a little bit like the open and the closed state of the stapler, that you learn those two extremes because they,
if the color.
because they are essentially encoded by static features. They're not encoded by
Right.
change.
Right, I think so.
So I guess if we did have something where like color was slowly changing,
Right, if you look
that
at
would be
something
encoded.
and the color
Mm,
slowly changes, if it changes slowly, you actually don't notice it. This is a visual illusion. Have you seen this?
Yeah.
You look at something and it's blue and they come back and you're just looking at it and slowly, and it turned to green and you have no idea that it turned to green because it didn't change enough to record it as a change. And so it just is lost, you know?
Can't see us if we don't move.
Right. Anyway, if we all understand this idea, we can get off of it. It's just that everything we know about how things move through space has to be, it's mostly encoded in the time slices of the behavioral model, which is greatly assisted. Our inference of what behavior is going on, if we're trying to recognize behavior, is greatly assisted by knowing which way the actual pieces are moving, right?
Right.
It's like if I saw someone dancing, and maybe I have like motion capture dots, right? And there's a body, I don't recognize this body, but there's some motion capture dots. If I just showed you one set of dots, and then it blanked the screen, and I show you another set of dots, and then I blank the screen, and I show you another set of dots, you'd have much more trouble understanding the behavior than if the dots moved. And in which case, I'm going from a feature which is just has no movement information. So maybe both features, the left and right movement, go to get both going rapid. But as soon as I know, oh, the movement of each of those dots, meaning I know it because the feature encoded it, then it's like, oh, pops right out. It just comes right out of you. So it's very, very helpful to have that knowledge to infer something, but it's not actually we're not taking advantage of it in terms of any kind of path and like applying motion to the object. Anyway, that's the idea, and of that one. So I like it. It may not be right, but we can go with it for a while. This just changes my thinking a little bit about the models. Now we can think about any attribute, regardless of anything at all. It could be high level concepts. It doesn't really matter. Mini columns represent the presence of an attribute. And the behavioral model just says, okay, now there's an attribute here that wasn't here before. That's simple. May not be right, but it's simple.
I'm imagining a scenario where you learn the stapler, you learn its behavior. Later in life, you walk into a room and the stapler is in the intermediate
Right.
position.
How did you recognize it?
Yeah.
Yeah, I don't know. It's a good question. I don't know the answer to that question. I also don't like the idea that I have to learn every position of the stapler,
Yeah.
right? So that seems impossible. In fact, if all I saw the stapler opening and closing, one of the problems we had is you can't learn every position of, it's moving. And so the morphology is changing. You don't really have the opportunity to learn what its morphology is in those in between points. That was one of the things we were struggling with.
Right.
So we got rid of one problem. Now we introduced another problem, which is like, well, how do I recognize it when it's static in between, right?
Mhm.
Actually, I mean, I think you would actually take a bit longer to recognize it. And what you could be doing is you just recognize the top of the stapler in one orientation and the bottom of it in another orientation.
Right. And then you have to yourself follow the path of it using the behavioral model, and which takes some time.
Yeah.
So we can try some extremes here. Imagine if the stapler opened very quickly. It was like whoop, and whoop, 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 right? There's no possible way you could ever learn the in-between points, right? You just can't.
Mhm.
And it might, and I think, but you could imagine it. I think Vivian probably got the right idea. It would probably take longer to do that. It would probably take longer. It's also interesting, we saw these examples when you could have a change, and a change happens very quickly, and there are actually no intermediate states. The brain actually perceives that there are intermediate states. It perceived it moved. Did we look at some examples like this last week? I forget, but there are examples where you can show there's two things. We could look it up, perceived motion or something, but you have, if something appears, it goes away, and something else appears, your brain it thinks it moved there.
The Christmas lights when they light up.
Or literally movies like 24 frames per second.
Right, I guess that's an example, but that's right. But it seems a little bit.
I mean,
weird.
but it works even with like fairly slow animation, like
Right.
I think down to
these are things
like
that you
a few
these are
frames
things-
per second.
These are things that you wouldn't expect to know the movement. It's not like I show you my hand here and then my hand here. It's like they show you some, letter A and then there's letter A. Well, we don't normally see letters move, right? We don't normally imply, but maybe if I saw it in a movie, I might say, oh yeah, well, I know their hand is moving. I'm gonna expect it to continue moving. This is like, no, this is an object. You don't expect it to move. You show it again and the brain says, oh, it moved from A to B. It moved from here to here when it didn't. But you perceive the motion. This is just a data point. So maybe, I could actually imagine in between states that I never saw. Right? I could say, oh, well, can you show me what it looked like between these 2 points? I go, oh yeah, sure I can. So it would be right here. You never saw it there. That was never anything you saw.
That's because you're anchoring to a behavior of the movement. Just you saw these two features and you think that this is the behavior that happened, the movement.
Right, but what does it mean? I didn't actually observe it, right? So all I observed is there was a state of the object here, and then there was another state of the object here. Some feature moved from point A to point B. And the behavior that was actually occurred is this feature disappeared and this feature appeared. And yet we perceive it moved, okay, and then also we could perceive, then I could ask you, what would it look like in between? You'd be able to tell me. I mean, it seems so trivial, but.
You anchor to the wrong behavior.
I'm not sure I anchored to the wrong behavior. It got the behavior, I'm just using this as an example of, I can predict what it would look like between two states that I actually never saw. Right, so this is the question about how do I predict what the state will look like if the staple goes whoop and whoop and whoop and whoop? How do I predict what it would look like here? You might say, well, I saw it moving through that position. I learned what it looked like there. And the example I just gave you says, no, you never saw it in between. You can infer what it would look like, but it actually was never there. You never saw it here. I mean, it'd be like the staple never actually appeared in the middle. It's just, in fact, what I'm suggesting, if this is right, I'm not saying this is right, but if this is right, and we only record static things and changing things, then the only time you learn is what the staple is closed, and you learn when the staple is open. Then when you're moving in between, there is absolutely no morphology model. It's just movement models, and somehow that's like the two dots moving. And you can infer, as Vivian said, you would infer, take longer, you'd have to infer what it looks like in the in-between state. Somehow obviously using the behavioral model, right? Somehow the behavioral model says, the behavioral model would encode all those intermediate states. Because they were changing, those features were changing throughout their cycle. So the behavioral model doesn't code it, but so now this gets us back to the basic problem we were struggling with, which was how do I predict, if I've learned this model with a black stapler of a certain shape, now I'm looking at a pink stapler with a slightly different shape. When it opens up, I can predict, I said, what would it look like when it's open? I will be able to predict what the pink stapler top looks like when it's in this open position, even though I've never seen it like that. How do I do that? That was.
Yeah, and I guess in general, it feels like that kind of sort of path integration or whatever, that like slow thinking to imagine that is definitely easier with some sort of child-like representation of the, or like breaking off of the sub-object, even if that's happening in one column, because then we're not trying to predict point by point how everything's changing, but it's kind of like, well, I know in the behavioral model the stapler top rotates, so I'm just going to do a kind of coarse approximation of that rotation.
So just review, I think we looked at two ideas there related to that. I proposed the idea that this could be done by having two columns in a hierarchical arrangement, where the parent object is the entire stapler, but as part of the stapler starts moving, we invoke the model of the stapler in the lower column, saying, but only attending to like, it's like the rest of the staplers are occluded. So it's like the lower column's watching the entire stapler rotate, but the rest of the stapler is included, but it would make good predictions about the top. And then Vivian suggested that maybe this could all happen in a single column, that within a single column, you can alternate between the full stapler and the top of the stapler and somehow keep both of those models. The two stapler models are in the same column, but we're occluding part of it and rotating it.
Yeah, and I wrote some thoughts on Slack, which I can go through on maybe how that could work.
Oh, I'd like to do that. Sure, why not? I didn't see it.
Okay, yeah. I mean, it's not super coherent, but
which one do you propose? Are you looking at the two
so
columns?
it's kind of a combination of those two, where it's accepting that there's kind of this parent-child hierarchy, but trying to put it in one object. And I guess one way to view it is that you kind of have the input into L3, like the movement and all that. That's kind of, that low-level information is telling you kind of where you are in some behavioral space, but that we kind of in that kind of like attending to just a part of an object, that gives you kind of like a region level state. So it's not a location by location state. It's not a global state for the whole object, but it's basically a state for a location region.
Right.
And whatever, so it's almost like having two behavioral states. But that high level one, which doesn't cover the whole object, that's what you condition on when you try and predict, like, okay, with the morphological model based on its rotation and things like that, if I move, what am I going to observe?
It's sort of saying, can I using the change detection, can I isolate a region of the parent object that is by sort of enclosing of the change? I can say, okay, that is a separate item, right?
And then we kind of talked about on Saturday, but in order for that to work, like when you go from one subregion to another, then you're going to have to kind of shift that attentional window.
Right.
But then that, you could be attending at one point to the top of the stapler, and then you could be attending to like the base plate, and like that kind of region level state is what's necessary to predict what you're going to see following a saccade. But the very low level like changes coming in, like at L3, that's necessary to infer like where are we in that, like okay, I'm in the top of the stapler and it's moving in X direction.
Well, I like that, although that didn't address the question we were asking. Is it in a single column or multiple columns, right? It just says,
So I guess I was thinking
This
of
is
that
a
as a single column.
well, what you're saying is, I think we have the information to break off a part of the stapler that we can consider as a movable subunit, right? Isn't that what you were saying?
Yeah,
Okay,
but I guess that could be sort of ascribed. It feels like at least in a single column
well, it could
at a
be,
given point in time.
it could be that, I think, the two
And so
proposals.
so like the whole object, like it's always like stapler, but the behavioral state is more specific to whatever region is changing basically, and which is being attended to.
Well, I think,
And you can only really make predictions about that
but
part.
wouldn't the behavioral state include, I'm thinking when you're talking, I'm thinking about the stapler opening with the weird behavior I talked about, which instead of the whole top of the stapler moving at once, that
Yeah,
part of it opened like a little door as it went up.
yeah,
Right? So there's multiple moving parts, right?
yeah,
In that example I laid out, there were three moving parts. There was the bottom of the top, and then the two little doors that flipped up from the top. And I would think that the behavioral model includes all three of those things.
yeah.
Behavioral model of the stapler, so it would include all, that's what I'm thinking, but maybe I'm wrong. And then, but somehow, because those individual pieces are moving, there's like every piece has its own little surrounding, sort of moving edges that sort of you could use it somehow to isolate particular, the three components. Like, okay, I know that because there's a boundary around these, that's one component, there's another component, and I think you're saying I could attend to those three, I could attend to the one door opening, I could attend to the other door opening, I could attend to the base of the two doors. In that case,
But yeah, you probably couldn't understand the whole movement with a
right,
single
in
glance.
that case, ultimately, I would think, oh, I'm gonna learn that this is a compositional object where there's a stapler has the foundation stapler, and then it has a plate that rotates up, and then there's two more plates on top of it that open in different ways. And so there would be four components, well, there'd be three child objects to the stapler. And those three child objects are moving, can move independently.
They're moving in sync too, right?
Yeah, but they are moving in sync, but I might still view them as independent objects. I might say,
But like, yeah, so you want to apply the to like a general hinge behavior to both doors, I guess, but you also want to represent somehow that they are the movement of one implies movement of the other.
So I think the parent object, one way you might think about this, ultimately you might say a model of the stapler says, oh, I have a stapler with three child objects, and the three child objects are the moving plate, which is the bottom of the top, and these other two parts. And so now I'm described it as a parent with three children, and the children are moving a certain way. That's not how I started with, because I didn't know that until these things start moving. So this gets back to the idea, like, when do we break off a child object? It seems really nice that you could break off a child object if part of something moves independently, right? That would be a good reason to call it a child object. And so this could then say, oh yeah, staplers were one thing, and now they're four things. Or, there's one thing with three child objects, and I have new sub-objects, something like that.
Yeah, and I also wonder, maybe it's something in between where, like, depending on how complex a behavior is, we're more likely to rely on a hierarchy with kind of location by location binding, but that with some behaviors it's sufficient to do more that kind of sort of localized attention within a column.
Yeah, it seems like you have to do the localized attention before you've learned that it's before you've learned separate child objects, but then eventually you could learn to represent the top of the stapler separate from the bottom, and then solve it with hierarchy.
So can I talk about an adjacent issue that we've.
Sure. By the way, is it possible to put on another laptop screen just to see you guys? Because I feel like sometimes, people naturally use hand motions and stuff, and it'd be useful.
Um,
Thanks.
this is an idea we talked about, but I think it might be essential to solving all these problems. This is the idea that, where do certain attributes get represented? So I was thinking about, I can talk about it in terms of melodies. Let me start there, because it's an easy example to make it clear. But the same problem exists in physical objects. So in the melody example, the melody consists of a series of intervals. That's the definition of a melody, and that would be in the behavioral model, right? It just says there's a series of intervals, that's it, and at certain timing. By the way, the behavioral model can track multi-part voices and things like that. It all works. But when you hear a particular melody, it's in a particular voice. Like, meaning like there's an instrument or a person singing, or it's a dog barking the melody, right? And that voice is a complex thing. It's like an attack, it's overtones, and how those overtones decrease over time. That's what makes a dog sound different than a saxophone versus something else. And that, in some sense, is the feature that's implemented at that point in the melody. And without any additional knowledge, I would assume that that feature appears at each note in the melody. So like if I'm hearing a saxophone, I'm going to continue, unless I know, I've learned that it changes from a saxophone to a dog barking, I'm going to assume there's a continuity of the saxophone. Yet the saxophone sound isn't part of the melody, right? But it's also itself a time-based dynamic thing. It's not a static feature. I can't represent it in the morphology model because itself has time, and I can't recognize a saxophone note without having its own time signature and changing its own behavioral model. It's a much faster one. It occurs very quickly in time versus the note to note. It's faster than that, but it's still, so I'm asking myself, well, where is the feature this is a feature which in some sense is not part of the behavioral model of the melody. It's just a feature that occurs at each point in this melody. But that feature itself requires a time-based model.
Do you think it's just for recognizing like the temporal signature of a saxophone that could be done more subcortically, or like pre-processing of the audio?
Well, there would be pre-processing of the audio, but I don't think it can be handled subcortically. I think this is the more general problem. And it relates to the problem we were dealing with, how to represent features on an object. So imagine our stapler, as it was opening, there was a little symbol on the side, and that symbol was the Starbucks symbol. And then it changes to this, and when it's halfway open, it changes to the Pete symbol. And when it's halfway open, it changes to the Phil symbol, right? Well, that's not something like color. That's not like black or something like that. That's like, I had to say this new feature appeared, and it's a complex thing, and it's like a child object. So I can say, well, there's a child object at that location that appeared. But those are very complex child objects. I can't represent them in a set of mini columns. Unlike edge or color, I can't represent coffee logos or logos in general or images in general by a set of 100 mini columns. It's just not enough information there. And so that tells me that I'm relying on a child object recognized somewhere below. Yet I don't know how to represent it in the model, in the parent object. In the stapler object, I don't know how to say there was a Pete's logo at this location. I don't know how to.
Yeah, this was, I guess, another thing I was posting on Slack about, because, yeah, it feels like if you use multiple mini columns, like essentially an SDR across mini columns, rather than assuming one mini column is dedicated to a particular type of child object, that at least makes it more tractable. And like,
right, but I don't think
I appreciate that, like in V1, we look at mini columns and they tend to correlate with like a very simple feature or an orientation.
Right,
but it may be that in general, it's like features are represented by a set of active mini columns.
It could be, although it doesn't feel right. I don't see evidence of that anywhere. Mini columns tend to have sort of well understood receptive fields. They tend to be things that representing things that can be there isn't too many of them. Uh, everywhere I look, it's
Well, that's
like
only
that.
really in V1, right?
Well, I don't know, maybe. It's, if I, then I think a lot of the mechanism wouldn't work. It's like, how to describe it?
And then you would still use neurons within mini columns to define like a unique feature at a location.
Right.
So it would be kind of like
Well,
a
first of all,
SDR within an
even
SDR.
even in the best scenarios, like even if I have, a millimeter wide column, I only have several hundred mini columns. I don't have thousands. I've got several hundred. And mini columns tend to be active not as an SDRs, but as sort of, if I look at like the edges, it's like, oh, there might be 10 or 12 mini columns representing edge orientations, and at any point in time, 3 would be active because it's like, I think 3 or 4 that might be in that range. It's not like I have this big vector and I'm really sparsely selecting from it. And even if I use all the mini columns in a column, I don't think there's enough. There'd be, a few hundred at most. And that's not really enough to represent really meaningful SDRs. I don't think it's enough. I would have to have, a minimum of 20 active mini columns, let's say, out of 200. So that's a 10% sparsity. It just doesn't, I don't know. You might be right, Niels, or that may be correct, Niels, but I don't think that's right. It feels like something else is going on. And again, remember, think about the melody. The thing that I'm looking at actually has its own time basis to it. It's like I can't represent the saxophone note with a set of mini columns in the static model. I don't know how to do that. It seems like I almost have to be using a hierarchy in some sort. And then even when I have hierarchy, I just don't know how to make it work. I just don't know how to, we'll go back. It almost feels like there's a separate representation of saxophone note that's stored someplace. And I'm saying, okay, just keep using that in every attack. Just assume it's the same thing over and over and over again. But it's stored separately. It's not actually stored as part of the morphology model or the behavioral model. It feels like, it's like in the melody example, I have the change model that is the actual melody. And then the morphology model, the equivalent of that would be the actual note I'm hearing at this moment in time. But somewhere else is saying, oh, what should that note sound like? It just feels that way to me. I might be wrong, but it feels that way to me.
I don't know if this helps any, but it seems like part of the solution is the fact that the behavior model only encodes changes. So even if I get input for a completely new instrument I've never heard before, playing a melody that I recognize, that feature input to layer 4, I would just assume that feature remains constant if there's no change for it encoded in my
Right.
behavior model.
Right, I guess that's what maybe you're saying. If it's a novel thing, like I never heard dogs singing the song before.
Yeah, or like a voice of someone I've never heard before.
Right. I'm not sure where you're going with this.
That would solve like a melody that alternated between piano and saxophone notes, I guess.
So you can learn this, you would learn that transition. It's like.
Yeah, so then if there is a change in the feature, it is stored in the behavior model.
Right.
But I know that if it's not in the behavior model, I keep predicting the same
Right,
feature.
but what I'm struggling with is how do I even apply the saxophone to each note? How is my brain predicting the saxophone note if I haven't seen a change? Where is that playing out of the saxophone note occurring? Where did I store it? Where is it temporarily held? It's like, okay.
Yeah, it would just be temporarily
But where?
held, it wouldn't be
Yeah,
stored.
but where is it?
Well, yeah.
Well,
I guess you get the
unless it
feature.
was, I learned this melody the very first time, it's really a famous saxophone solo, then I would know there's supposed to be a saxophone for this particular,
Yeah, but it can't be stored because you can hear it in a new voice
Right.
or a new instrument, and you predict it will keep the same kind of signature sound. So you would just have like a memory or constancy in
But where
layer
is it?
4 of like whatever feature you get as input in layer 4. You
Well,
would
I would say, first of all, it could be just a random set of stuff, but I don't,
So you just.
even in
Except-
layer four, if I don't represent it in mini columns, I can't represent it as an SDR because the whole point of the mini columns is the mini column is the unit of change. It's not the cell, it's the mini column. If something's gonna change in this object, it's gonna be recoded as the unit of the mini column because I have to do these changes in high order sequences. So I can't, it's basically the mini columns have to define everything. I can't rely on an SDR to do that. And I can't transition SDR to SDR. It's basically, I have to represent the saxophone as a set of mini columns. And Neil's saying, oh, I can have a lot of mini columns. Yeah, but I don't think we'd have enough. And I think in my mind, the mini columns actually have to represent something physical. They have to be a real thing that can be detected, not something that is inferred from a sequence. It's gotta be like an edge or a color or, a texture or a sound starting. It can't be, anyway, I haven't heard an answer yet to this. I think it's somehow.
Possible there could be some analogy to the way we're talking about color on Monday. So the center of the column would be representing sort of like morphology or color, I guess, and the outer like interblob areas representing morphology.
Right.
Some kind of separation like that between the model of the intervals in the melody with the texture of the melody.
Right. The problem with that is I still have to represent the saxophone with a set of mini columns and the same set of mini columns that have to represent every other instrument that I ever might hear.
Yeah.
And there isn't enough mini columns to do that. And it just wouldn't work. I mean, there is no point, there's no single thing I could detect that says it's a saxophone. It has to be a combination of things over time. And so,
I mean, if you had a low level column that, like, if the sound of saxophone almost was like an object itself.
right, that's
then-
where I'm
But then I
coming to.
guess, okay, but then I guess it, like, I feel like taking a step back, about like the number of mini columns and stuff. It feels like this is a general issue with like anything with hierarchy. Like if we're going to pass the object ID from L3 to L4 in the next layer, like we
Right,
somehow need to be able to uniquely encode that.
Right, I agree. This is a general problem. We didn't really deal with it in the past. We just waved our hands. We said, oh, we're at some edge on the object or some point on the object, and we're gonna sort of, there's a feature there. Oh, the logo is there. Okay. We didn't ask ourselves, how does the logo ID get encoded in mini columns? I just assumed, oh, the logo is gonna be some high order state of the mini columns that are active, like, oh, there's an edge, and the individual cells that I pick in there are gonna represent the logo. So, but that is weird because then if I was at a different point or as a different point in the object, I wouldn't pick the same cells. It didn't work. We never tried to get it to work. So I think there's a general problem for our morphology model. We don't know how to encode logo in layer 4. That's something like that. And what we're struggling here with the behavioral models is the same problem.
And so just to clarify on the saxophone example, the issue you're pointing out is more about that actually detecting the saxophone is in itself like a temporal behavior, and not,
Right,
the problem you're talking about is not about like constancy. Like if it was color, it would be easier to do.
right.
But
And the
more
reason I
about-
brought the saxophone is because it proves that you can't do that in layer 4. Layer 4 cannot learn the sound of a saxophone over time. I can't, right? I can't do that. So it proves that I can't just treat it as some static SDR that I pass in. I mean, I can't represent it in layer 4. It just proves that I have to have another place that's doing inference over time.
But that's just because the saxophone is like an over time kind of detection.
Right.
If it were just color, you could represent it.
Right, well, I think, here's what I'm getting at. A column, take a column, the mini columns, in my mind, always have to represent something you can actually name. It's a thing. They're not part of a distribution. Mini columns are always like, it could be moved, the center is moving in this direction, that's a thing. Or there's an edge at this location, that's a thing. There's a color at this location, that's a thing. And I can enumerate all the colors, I can enumerate all the orientations, I can enumerate all the different directions I can move. So each mini column can mean something. It's not a distributed representation. Oh, yes, there are multiple ones active, because when I'm moving in a particular direction, multiple mini columns will be active, because some are moving like this, some are like this, and this, and like this. But it's not, they are not distributed representations. Each mini column means.
Do we know that for sure? Because I mean, probably most of the
but-
experiments that have evaluated that have used like very simple, you know, a Gabor filter moving.
No, we
through a
don't know
field or
that for
something.
sure, but the entire, our mechanism for sequence memory assumes it. If you say the mini columns are distributed, then,
Can't the sequence memory couldn't a set of mini columns predict a set of mini columns rather than one to one?
the sequence memory has this basic property where you represent something in mini columns, and then you represent it uniquely in the cells. Right?
Right.
And so the thing I'm representing always has to be represented in mini columns. And then I can say, okay, that thing, I can now say, I can represent different things. I can say there's an edge to the object. And now I can say, oh, that edge, I have many different ways. That edge is occurring at the left end of the tiger. It's occurring at the front end of a stapler. Those are like the, what was the name of that guy? What was the name of those cells? And those cells.
Yeah, border ownership cells.
Border ownership cells, thank you. So we know that
But yeah,
they
it
exist.
feels like that it would still work. And
I don't see how
in
it
some of the
can.
HCM papers,
How
I thought
could
in
it?
some of the HCM papers
Because-
you do have multiple columns active, but like with
Right.
only some cells
When
active.
we did this in the, when we first wrote the temporal memory algorithm, we didn't understand a lot of this stuff. And so we basically said, oh, there's this mechanism to learn high order sequences. And, but always when an input came in, like an element in the sequence, it always invoked the same set of mini columns, always. It didn't invoke a set of cells, it invoked the same set of mini columns. The mechanism.
Yeah, well, why wouldn't that happen here? So like, let's say the
Because
saxophone
I
is
don't have enough mini
identified.
columns to represent all, I have no way of representing saxophone versus oboe versus dog versus xylophone, you know,
But
I don't like
I
doing
guess,
that.
okay, but so, okay, I accept that maybe the numbers just don't work out, but it seems in principle, the sequence memory would still work. Like if you,
Yeah, I can learn any arbitrary sequence of SDRs, and that's what the sequence memory does. But the whole point of the sequence memory is you have to come in with a particular item that you're now going to represent in many different contexts. That's the whole point of it.
which is like if it was a child object, whether that's saxophone or logo or whatever, let's say that activates mini columns 4, 22, and 109.
Right.
Like every
Right.
time you see logo, it's going to be 4,
Right,
22, and
Right.
109.
And then but I'm saying I don't have enough mini columns to do that. It's not going to work. I can't, the mini column can't be, I just don't have enough mini columns. It's like, it seems to me like I can define certain things like in an object. I can say it's got its edges and its colors and maybe a texture or something like that. But when I assign Phil's logo, I can't represent Phil's logo in a small set of mini columns. You know, from every other possible feature, there are thousands and thousands of objects that could be a feature on the edge of the stapler. I can't represent them all mini columns. It's just not enough mini columns to do that. So I just don't see a way around it. I'd like it to work, but I don't see a way around it.
Yeah. Yeah, I mean, it feels like for this reason, like not every column could learn about every object. Like,
No,
it's
it just
going to
says,
somehow rely on kind of
it somehow says,
separation of, yeah.
it somehow says that until a further notice, keep assuming the same thing that happened before. It's the same logo or it's the same sound of an instrument or whatever. But that is not going to be detected in the parent, the parent column. It's like it's going to be detected in the child column. And so the child column somehow we have to, you know, just think about our. Let me just aside from imagine our compositional model, right? How we do composite objects. There is a back connection between the parent and the child, and that back connection is very specific. It says on this location on the parent, you should be on a particular location on a particular child object. The parent, this doesn't take any extra storage in the parent object. The parent object doesn't know what that is. It just says, I'm at a location you learn to associate with whatever you are doing down there. We have the right bandwidth going backwards, meaning I can associate a very specific object with a specific location on the parent object, as long as I'm going backwards. But when we go forward, now we're talking about forward, like, okay, I'm gonna associate a particular child object to a location on the parent object. That's the one we're struggling with. So there is a connection between the parent and the child. It's just that the parent, I'm having struggle, how where do I store, how do I store that child going into the parent? Maybe I don't need to.
Maybe you're not storing the full child, you're storing something that guides the lower level to integrate the sensory input that's going into it and the higher level guidance that's coming.
Right, but isn't that what I just described, the back projection? That's like the parent can tell the child, the parent doesn't know what it is. I'm on a coffee cup. I don't actually know what's on my location here. I just know that at this location, somebody else may learn that there's a logo there at a particular orientation, a particular thing. So I'm the coffee cup with the logo. I said, I don't know what that is, but you know what it is because you've already learned what you're doing at this location. So the child, you take care of it. That works in the back direction. I think that's what you were just describing. There is an association between the parent and the child where the parent doesn't really know anything. It just says, I'm telling you my locations, you figure out what was there.
Yeah,
You know?
knows just enough to guide the
It's
lower
not,
level.
it's very specific. It's like, this is a location on the cup and exactly no place else in the universe. We're right here on this point on the cup. You can associate what you were a logo at some point on the logo. So the backwards connection works. It's like if I was in the melody, I could tell the child, I don't know what voice this was, but you did, so you keep going, you know?
Yeah, I think we talked about this like maybe 2 years ago when we
Oh,
talked
gosh.
about hierarchy, whether we actually need to learn the connection both ways. So
We did
it
talk
seemed-
about this? Wow,
I
okay.
think, I think at some point I was arguing that it's a bit inefficient to actually store the location of the child on the parent and the parent to the
To do it
child.
both ways.
Yeah, to do it both ways, because you're kind of encoding some redundant information there. So what if the parent doesn't actually, we just have the connection from the parent associated with what the child should be perceiving, but the forward connection actually only tells the parent that a feature was observed at that location, or maybe something general about this feature, like there's a round feature there, or there's like an elongated
Well,
feature
let's
there.
follow this a bit here. Layer 3 is the quote input to layer 4 in the next region, right? That's the output of the child, it's a layer 4. Right now, we're talking about layer 3 representing the moment, I'm talking about representing maybe behaviors.
Yeah, that's,
So-
I don't, yeah, separate.
Well,
Anyway.
my point is, what if we said, oh, we're not passing up the object ID?
Yeah, just the orientation and. of
Or,
it.
I don't know what it is, maybe you know, but
You just pass the orientation of the child object.
well, I have to know the orientation of the child. And maybe I'm actually passing up something about behavior, maybe it's important to tell maybe, I don't know. I don't know about that. Right. Can we make this work if we don't if the parent-child doesn't know what it is? It's just, you're saying just the orientation.
Yeah,
That'd be clean.
because you could still make predictions about the features of the child object because
Yeah.
the parent has learned the backwards association.
Right.
And you can still recognize the high level object just from the relative orientation of the child object. Like if you have the fruit face, the banana mouth still needs to have the correct orientation,
Right.
but it doesn't matter for the parent object whether it's a banana or a carrot or whatever.
Yeah. So this is a pretty sort of radical idea, but not in a bad way. It just means that we were thinking about it a whole lot wrong. This idea says, oh, the child object doesn't actually tell the parent object what it's viewing.
Yeah.
It just says, I'm viewing something at this orientation. And then when the parent object projects back and says, well, whatever you're viewing, here's where I am. You do it as you will.
I mean, yeah, I like that. It definitely sounds
It's a
possible.
It's
But
possible.
it's also kind of it's weird because it's like just thinking about, you know, how you conceptualize a compositional object. like at some point you do kind of cognitively know that the low level pieces are part of the high level piece. But
You know, it's funny. I'm thinking here, like, do I actually perceive the child and the parent at the same time? I mean, do I perceive them as a whole? Or is it like, oh, I'm at the coffee cup, oh, look, there's the logo, now I'm looking at the logo, oh, now I'm back to the coffee cup type of thing, you know, it's like. There's lots of examples where there's child object and parent objects where you don't actually notice any of the details of the child object until you attend to it.
And you can get the rough information about the child object from, like, if you have a skip connections from the sensor to the, like, the larger, lower resolution receptive field projecting
Right.
directly to the
Right,
higher level, telling it some color
right,
information.
we have to, that's another,
Are we debating
Challenge.
here if the hierarchy is represented in one column? Or
No, just whether the lower level column actually, whether it actually sends an object ID to the higher level column, or if it just sends orientation of the child object, and then the parent object learns an association, a backward projection
so
that tells the child what features to expect.
let's think about the melody example. The melody is, the voice is a mini sequence. Okay, so let's say child object learns this mini sequence and it can play it back. At the beginning of the mini sequence, when the attack of the note occurs, that's when I want to tell the parent that, hey, something happened here, there's a new thing here. And the parent says, okay, there's a new note occurring, I don't know what it is, but there's a new note occurring. I'm gonna learn, I'm in my sequence here, and then, but it's associated back at that point, with, the location. I don't have to think through this, I'm just saying, there's an association back to the child, which is essentially says, you should be at, if I'm predicting the beginning of a new note, you should play back, a sequence that was you last played back. It's sort of like the child object says, I'm just gonna assume, I don't know why the child object would do this, but it's assuming it's gonna play the same thing over and over again. And so that every time you get a new note in the sequence, it tells the child object, you know, yeah, it's a dog barking, you know, something like that. I'd have to work through the details. We'd have to work through the details on this, but,
yeah, it would be reinstating more of like a behavior in the low level child.
right,
Right.
you would kick off that behavior. You'd want it to start at the beginning of the sequence of the behavior, because I want to play the whole dog bark or the saxophone note. So it'd be like, I'm telling the parent, at this point, something started. The parent doesn't even know what it is. Like, maybe I haven't even, the saxophone the sound of a saxophone takes some time to play out. What the melody is important to note that it started now. So you want to like say, okay, the note started now, the voice started now. What actually, it's going to play out in the child object, but the parent object said, oh, something started. And then later on, the parent object can say, you know, play that sequence again at the beginning. It's like saying, oh, I'm expecting the note to start here. And the child goes, oh, I'll play back the saxophone note, something like that. There's a lot of questions about this, but I think it's a good idea. By the way, this doesn't mean we still don't do temporal pooling in the child object, in the parent object. We still might label these things. I think we have to.
Which things?
You know, like we're now no longer sending up the name of the item to the parent, right? That was, we hypothesized we have to do temporal pooling to come up with a name for this object and then pass it to the parent. And now we're not doing that. We're not sending up. We're just saying an item occurred and we have to calculate its orientation or something like that. But we're not telling the parent what it was. I'm not telling the parent, oh, this was Phil's logo, or this was a Starbucks logo, or this was a saxophone, or.
You still do temporal pooling and vote on that.
Well, I would think, I'm saying we don't have to throw away temporal pooling completely, because one of my tenets is the brain has to do temporal pooling in every column. Otherwise, you can never name anything. So we'd still have to do temporal pooling, but that's, the output of that is not being sent.
It's being sent laterally, right? from
It's being
a-
sent laterally. In some ways, I like that. There was a lot of issues about sending names up the hierarchy, but so I'm just walking through the consequences of this. I from a compositional hierarchical point of view, I no longer need to have temporal pooled representations from a child. But I still want that for voting and other reasons,
Yeah,
right?
So
So
what are we
we're not
saying?
getting rid of temporal pooling, we're just not passing it to the next column. I'm just walking through the consequences.
So what exactly are we sending up? Just the orientation?
I think, the hypothesis right now is we're sending up
orientation.
whatever, yes, something, I don't know what orientation number it is, but.
Orientation of the first part of the sequence, like how?
No, of the whole object. There's like they're basically saying, the child is saying,
The orientation
something-
of the
some-
reference frame.
something occurred here. The child says, well, it's just basically the child basically sending up an orientation. It says, at this point, whatever we're looking at, here's the orientation of my object. And that's all it's sending.
Yeah, I'm thinking of a
And
melody.
right, and the parent is basically sending back, okay, well, we're now gonna connect between you and me, and so now when I'm at this location, you're gonna invoke the exact right point in your object. But no one knows, they're in separate rooms, they don't really know what the other one's doing.
Could a compromise be like it sends something up, but it's not like it sends a super unique fingerprint, or at least L4 is insufficiently.
Well, what are you trying to prove?
favorable.
Why go there? I mean, I think
I
it's
guess
nice.
to like bias, because like yeah, we can recognize a face made of fruit, but I'm pretty sure we would recognize a normal face much quicker.
Well,
Like
here's-
that information can be useful to
Okay.
narrow down the hypotheses.
Right. One thing you could do,
Or like even the Numenta
Right.
mug. Like
You
it's
could-
almost like how do you recognize the Numenta mug unless you pass at least some of that information up?
Right.
Because
Right.
otherwise
Right.
it's like you just have an orientation of a logo. And
Right.
sure you have the skip connections, but the whole point
So-
is that those are kind of too coarse to
so
learn
let's
another
let's
model.
assume the only way SDRs work is by association. So I could associate the logo ID with something in the cup. I could associate it with a location on the cup. I guess but that's a lot of memory. I mean, you can associate two SDRs. That's what you can do. You can say, okay, two people have two representations and they're kind of coincident, and I can say my bias is yours. It's just like voting, but you know, I'm saying something like the logo could vote on cup with logo, something like that. We just can't represent in layer 4. It has to be just, it has to be an SDR to SDR. So I'm with you. I think you're right, Neil. I think we have to still somehow bias the cup somehow.
Yeah.
Or
Or it's
we're
just
not-
like
or we're not-
it's like a highly redundant, like I cannot decode logo from that SDR in L4, but if I have the representation mug in the high level one, then the bit pattern is sufficiently like that tells me, oh, it's probably the logo with the mug, but that exact same bit pattern may also appear for guitar or you
Right,
know,
or
fills or whatever, like some other thing. So it would only get confused if you were trying to kind of reuse the same bit pattern in a similar context, which maybe is unlikely. I don't know. And then I guess the more familiar you are with an object, maybe the more neural resources you can dedicate to actually having a unique L4 representation. But yeah, maybe like the default is it starts at like just
Well-
orientation and then
well-
gets more specific or.
let's walk this a little bit. Now, and I'm taking your idea and walking back some of the stuff we said. Child object has a child object ID. I'm looking at the Numenta logo. I could associate that with any kind of SDR in the parent object. For example, every SDR in layer 4, which is, let's say this for the moment, just assume that's like the edges of the object. Every SDR in layer 4, or edges of anything really, or just any location, just basically, I could associate the logo object ID with any location, specific location in the parent object that's has the logo on it. I mean, it's just going back to what we were trying to get rid of. I can associate it with that. So I could say, oh no, it doesn't work. I don't know. I'm sorry. I'm trying to make I'm just trying to think of what are the options there.
Does it make sense what I was trying to say, that like, so I accept that like L4 probably doesn't have the capacity to be like, oh, this set of mini columns active means Numenta logo, and this set of mini columns active means Bill's coffee cup or whatever.
Yeah.
But if there's some like overlap in them, so like, oh, this set of mini columns means Numenta logo, and it also means chair, and it also means basket or something.
No,
But-
I'm not
but-
going there. I don't,
But-
I want to push back on that. I don't think we're pursuing the mini column idea. You might be right, but that doesn't strike me right. In my mind, I believe.
But I guess I'm just thinking that it would bias the high level representation.
I think, let's go back to the thing I just said. I said, you can associate SDRs with SDRs. So I have an SDR someplace and I have an SDR someplace else. We can associate it one way or we can associate it both ways on the map. This is a really good mechanism. It's high capacity. We can do millions of these things and not get, well, hundreds and thousands of them between two populations of cells. It's great. And so this pattern can evoke a pattern over here. What I think you can't do is go from an SDR to a set of mini columns. Because the set of mini columns is not an SDR. And I don't think you can do that.
Well, it's a low dimensional SDR.
Yeah, but it's not really, because the mini columns themselves have to have a specific meaning. They have to have a constant meaning. That's, in my mind, that has to occur. You can't say this mini column is now part of one SDR and now it's in a moment later it's part of another SDR. Because then you throw
As long as it reoccurs when that feature
No,
or
because
object
then you-
occurs in
then
space,
you-
why
then you
does it
lose
have
the
to be
ability to
like
do-
that is specific?
you lose the ability to do high order sequences. I need to be able to do high order sequences with mini columns, and high order sequences.
Do we need to be able to do it just in the mini columns? If we have the behavioral reference frame and the structured reference frame, that's where the sequences are existing. Like it doesn't need the HTM where it's only in L4.
In my mind, a layer with mini columns is a way of taking a representation that's not unique and making it unique in context.
Yeah.
Right, and so I can't make the mini columns be unique. They have to be non-unique. The set of mini columns have to represent something that's repeated over and over and over again, and now I want to represent a unique context. So I can't encode I can't use the mini columns as an SDR. Yes, I could still learn sequences of it, but it would throw away the idea that there's that they're learning something differently, representing something differently in context. You know, this is true for the grid cells. Basically, you're representing locations, but only when you look at the set of mini columns that's unique in context. You know, you look at there's a feature in layer 4, but in context, I have a unique way of representing. So I just don't want to go there where I'm trying to make it work, but I don't think I can go there where mini columns.
Yeah, maybe I can try and write what I'm thinking.
Okay, but before,
yeah.
right, okay, you can try to write it down, because I don't think it's gonna work. But I do think the idea that we could take an SDR in the child object and associate it with an SDR in the parent object makes sense. And this is the bias of like, oh, it's, a banana doesn't suggest a face, but, a nose does. I can still recognize the face with just a bunch of orientations, but if I see a nose, it's more likely to suggest a face. So then I'm asking myself, okay, if I have a child column and a parent column, and I have in the child column, I have an object ID, which I say is an SDR. What could I associate it with in the parent column. That's also an SDR.
Oh, okay. So, I don't know if this is where you're going.
Well, I'm thinking what are SDRs that would be associated with this? One would be the location on the object. The location signal is a unique SDR that could be suggested by this, but that's not very good because it would suggest all the locations that have, well, it could, I don't know, but anyway.
What if it's kind of like a lateral voting connection? And it's basically, I mean, we don't always have to vote on the same object ID. It could just be biasing. So what I was wondering, what I was thinking is the problem is if the higher level column has learned a model of a mug, how does it know to predict the logo down, the Numenta logo down here?
I think we solved that problem.
Yeah, but if it has learned mugs with different logos on it, and it doesn't get the logo ID as input, how does it know this is the Numenta mug
Right.
versus
Right.
Pete's mug or whatever?
Right.
And the voting, if we could vote, that could solve it because this one could say.
I don't know what you're
right,
voting on, voting object ID.
we would learn an associative connection between Numenta logo.
So you're voting,
and
you're
Numenta
saying,
cup
you're saying,
ID.
you're saying,
Versus, like,
the
Pete's cup.
logo is voting on the Meta cup.
Yeah, the logo would bias that the high level
Okay,
column would
so,
detect the
right, so
Numenta cup.
I think, Neil's correctly pointing out, we do need to send something up here, right? You need to send something about the logo, let's go up to this guy, that's the assumption. Now, the problem with this is, well, it's not a problem, but it's basically saying, I'm associating the logo with the entire object here. Okay, maybe that's right, it's certainly not specific to where it is in the object.
Yeah, it wouldn't
Okay.
say where it is, it would just bias that this is the Numenta cup versus Pete's cup, and that would then tell the backward projection what features to expect at that.
Well, that would be, what's funny about this is, well, not funny, this is suggestion. Layer threes, they say, oh, layer 3 cells project to layer 4 in the next region. But they also, layer 3 cells vote with layer 3 in the next region.
Yeah, so it would be
It's-
that, it
it's
would be
kinda like-
layer 3 to layer 3.
I don't
voting.
understand, but you're saying this is the voting one. You're
Yeah.
saying, so basically we could just assume we're voting, but we're not voting on logo, we're voting on, this child is voting on
It'd be
cup
like,
with logo.
if the lower level is detecting an eye, it makes it more likely that this one would detect a face.
Right.
But it's not telling it, oh, the eye is at this location, it's just saying, eye gives you some context for the potential objects you might be
It's funny
detecting.
because if you look at like a Picasso picture where all the facial features are mixed up, it's kind of, what's disturbing about it is you keep thinking it's gonna be a face, but then you can't make it work. It's like, oh, like you see the nose, oh, that's a face, no, shit, doesn't work, oh, that's an eye, oh, no, shit, doesn't work. It's like, it's sort of suggesting what you're saying, it's like, every time I see those components, I say, oh, I'm voting, it's a face, and then it doesn't work.
Yeah.
Where if you see the banana, it's less annoying. If you see the banana for a nose, it's less annoying. It's okay, fine. Anyway, okay, so the suggestion here is a simple one. We're voting on object ID between parent and child.
Yeah. Because voting doesn't say that they need to, like, when we vote, we never make the assumption that they use the same SDR to express the same object. Like, if we vote laterally on cup, this one has a totally different SDR representing cup
Right,
than
right.
this one.
And also,
So there's no issue of
there is
doing,
no, it's just whether there's a good association.
yeah,
Obviously, in the hierarchy paper, I was just editing it, and there was language in there, I don't know who wrote it, but there's language in there that says, in fact, I might have just removed this language, so I might have just commented it out, because it was long and complicated. But it was saying, why is there a discrepancy between parent and child objects? And I said, well, what can the child object tell the parent object? The child object can say, like, I'm seeing a logo, you should be looking for something with a logo. That's all it's saying. I didn't say anything else. It didn't say like, you should be looking for something with a logo at this location. It was the language I wrote was, there's a logo down here, and because I was thinking like there could be lots of objects with logos, like it can't tell where it is on these other objects. You can't say what object it is. It just says you should be looking for something with a logo.
yeah, so this could also bias it to detect a Numenta t-shirt, for instance, if the
Well,
child.
you just introduced a whole. Oh yeah, right.
Like if the child object detected the Numenta logo,
Right, Right,
We'll just
right.
bias
It
the
says,
parent to
you should
give
be
it
looking at, you should be looking for anything that has a logo on it.
Yeah.
Right. And that's how I wrote it in the paper, although I wasn't thinking along these lines. I didn't think it through. I just wrote it down like, oh, yeah, that makes sense. Or somebody wrote it, I think it was me, but I just deleted it, I think. So, all right, so that's, in some sense, does this work? Does this solve all the issues here for at least for the parent-child thing? We're voting.
It kind of works. I feel like, yeah, I mean, in theory, it could work, but it also feels like, yeah, it's not great either that we're not passing up kind of feature that's more unique to a location, because like one of the advantages of hierarchy that we've talked about is like we'll converge much faster, because you could say like, oh, now you should be seeing a logo because of where you are, or now you should be
But
seeing
we
a
do
handle.
have that. If we're on the logo, if we're on the cup model will tell the child model, you should be viewing a logo exactly at this point, and we can make a very specific prediction. So we're telling it that. So the backward projection is right. It's just the forward projection, which is the weird one we're dealing with here, right? Right?
Yeah, no, and I guess that's what I was referring to. But
Okay.
yeah, and I guess just the other thing is, I just know when we looked at these lateral connections across hierarchy, they weren't as prominent as we kind of thought. So I feel like if this is going to be like integral to hierarchical processing,
Well, we
that's
should
just
go
a
back
concern,
and
I guess.
do that. I guess this is one of those situations where I really want to understand the details of the experiments, because everyone's reports that layer 3 projects to layer 4. And that would be their bias going forward. And so they're going to report something different. What is it would be sort of contrary to that. And what is what's their methodology? How were they looking? What was, I'm not saying it's the empirical data is wrong, but it's one of those cases I just don't accept it. I won't accept it right on the face value. I want to dig into it.
By the way, on the topic of layer 3, we now kind of put the behavior model there as well. Could we
Right.
also say that like the behavior model is in the upper part of layer 4 and the morphology is in the lower part of layer 4? It seems odd to have the output layer be the behavior model.
Right. Well, no, the reason that there wouldn't be upper layer, lower layer 4, I'd rather do upper and lower layer 3. And the reason is the behavioral model requires apical dendrites to layer 1. It requires time.
Yeah.
So the general rule is that layer 4 stellate cells, it's mostly stellate cells. They don't have apical dendrites, so they wouldn't get any time information. Now, that used to be like, oh, all layer 3s are cells are stellate cells. Now people go, oh no, some are pyramidal cells. They'll find some there. But in general rule, the stellate cells, which are primary layer 4, don't get time. And the behavioral model would be all cells that get time. They all have to have an apical dendrite. So that could be either upper and lower layer 3, it could be upper and lower layer 2, it could be any one of those. Some people have made that distinction between upper and lower layer 2 and upper and lower layer 3, and other people say, I don't see that. But I would think that we could pretty hardly say stellate cells, non-ones of non-apical dendrites can't be part of the behavioral model, and the behavioral model has to have apical dendrites.
Yeah, okay.
And within layer 3, we can definitely have 2 layers there. Some people really, the layer 3A and 3B distinction has been made many times, even though, it's very vague. There's subtle differences, and I don't know if anyone knows about it. So I don't do upper and lower layer 4. I would do upper and lower. I got 2s and 3s, like behavioral models up there someplace.
Yeah, I guess, layer 3 and 4 works too, if we can say that there's different subpopulation of layer 3 that projects forward.
It could be, again, they already have been proposed upper and lower layer 3, upper and lower layer 2. So any one of those could be the behavioral model. As far as I'm concerned, we got lots of cells up there that are unaccounted for.
Okay.
Then we'd have to look at what it does require is it requires that there are 2 sets of cell populations representing a location that can anchor differently. So there'd have to be 2, like, here's something that's weird. Layer 6A and layer 6B look like they're so parallel that I would think, oh, those are the two reference frames, one for behaviors and one for the objects. And we've thrown in layer 6B as orientation. Orientation is something that does not have to be represented unique to the object. You don't need many columns to represent orientation. Head direction cells are never unique. They're, or at least the general idea of head direction cells are not unique. So it's not like, oh, I'm facing this direction in this object, I'm just facing this direction. So it's possible that layer 6A and layer 6B are the two reference frames we need for objects and behaviors. They would look like it. And then maybe the layer 6B cells that represent orientation are a small subset of layer 6B. And maybe not all of them, something like that. I don't know yet. And we have to work through that. But on the surface, if I just had to say, where are the other two locations? I would say 6A and 6B. And then I say, well, where are the two, what's the layer equivalent to layer 4? I would say it's in layer 3A or 3B or 2A or 2B, something like that. That would be the suggestion.
Shall we take a short break? By the way?
Yeah, I need to take a break.
Oh, get some coffee and stuff.
Well, in the bathroom.
Yeah, and I might sign up for the evening.
Okay,
Yeah, we're
just 'cause
recording,
it's-
so you can.
But yeah, please record.
well, your good contributions, Neil, so we'll miss you.
Yeah.
Catch you next day.
That's good. Yeah, have fun. It's a really cool discussion.
Yeah. Nice. Nice evening.
Thanks.
Feels kind of like we're doing a puzzle, and when you sometimes you're kind of stuck, and then you suddenly put one piece in place, and you can put in a bunch of other pieces afterwards. But then you notice that you put another piece in the wrong place.
In on-intelligence, I described figuring how the brain works like a puzzle. It's like a jigsaw puzzle. And I said, the problem is that there's like a million pieces and you're missing a lot of the pieces, many. And many of the pieces have images on both sides. You can interpret them differently. Like this piece can be interpreted A or it can be interpreted B. So you're trying to solve this puzzle with all these missing pieces. You don't know if you have even sufficient number of pieces to solve the puzzle. And the pieces can be interpreted multiple ways. I made that analogy and I was like, this is like crazy, it's like so hard. But in theory, we have enough, as you have more pieces. So what you end up doing is you end up putting a bunch of pieces together to solve some subset of the puzzle. That was like the temporal memory. So a small subset of the puzzle, but we got that one figured out. And then we're like, oh, now the morphology of objects. Oh, we think we got some of that pieces. And then now we're like, okay, we have some of these pieces. Now let's connect them together. Now see if we can figure out the ones that are missing in between. And sometimes we have to make up a piece because no one's actually observed it yet in biology. So like, oh, that piece, this piece should be here. We don't have it yet.
Some pieces have fallen under the couch.
Yeah, you lost them. Oh, and the other thing I said, you have some pieces and then someone comes to you later and says, oh, you see all these pieces? They were wrong. Let me take them away. I'll give you some new ones. That's when the scientists come back and say, well, that wasn't the right observation. This is the right observation. It's like, wow, I've been working trying to figure out those pieces and now you take them away from me. Oh, it's so hard.
You think you'll end up writing another book?
I don't know, only if it's necessary. I think, I mean, it's not fun writing a book. It's a lot of work. But, I thought about different books I could write, very different types of books I could write. I could write a book about future of humanity, so expanding on the parts I did in the last part of my last book. I could write a book like core to this, just like, here's the book on brain theory, everything we've learned in a nice cohesive format. So more of a documentation than it wouldn't be a big seller. It would be more like documenting, a different form of documentation. Then I'm saying, well, do we need that? Because we got videos, we got all the stuff, and maybe the books are old school. We need the book. I don't know.
Yeah, my bias would be towards, the brain theory book, like once give it a year or two, whatever gets worked out here, taking the concrete learned aspects and basically augmenting the last book.
Yeah, well, you could really just, you know, but then that book would go into lots of details that would turn off most readers,
True.
right? It would be it's a small, it would not be a big seller unless, you know, unless it was somehow got popular, A Brief History of Time by, what's his name? Stephen Hawking. That was a huge bestseller, but if you read it, it's a damn hard book to read.
Yeah.
It's like, oh my God, I just got lost in it over and over again. It's like, well, why was it such a huge seller? He has a great title, it was short, and became famous. So everyone felt they should buy it and try to read it, but very, very few people could make it through that book. So that's the exception. Like, you can have a really dense book and still sell a lot.
Well, it probably did sit on a lot of bookshelves.
Oh, I'm sure it did, because, you know, look, I was really motivated and I couldn't get all the way through it.
Yeah, I still have it on my bookshelf and
Did you start reading it?
no, I
See?
got it on my to read pile for like 10 years. So
If you do read it, it's hard. You know, I found it hard, and I love that topic, you know, I found it hard, you know, yeah, it's too difficult to read and dense, and I can't even say it was easy, well written.
it's always so tempting because it's pretty small.
Right,
Like it's,
right, oh, it's so small, I get it, what a great topic, we'll learn all about time, and it's a little fun. It's just really, really hard. And also, he was a very famous guy, because his disease, you know, it's like, here's this guy doing this great science, he can barely even speak. It's, you know, wins all these prizes, so yeah, let's read his book. So where do we end up here? I think we're going around in circles a little bit. I think we have a clear idea of at least how we project forward. And I think we also maybe concluded that, and Niels is gonna push back on the mini column thing. I don't wanna go there, but for the moment, I'm gonna go for the voting. All right, SDRs, the child object basically just votes on what the parent object would be. And that's
Yeah.
probably one directional. I don't think I would need it. And by the way, some of these layer 2 and 3 connections are one directional. So I don't think I need to go the other way. I don't think that, you know, the cup has to predict that there's a logo, because you can't be certain there's a logo. Right?
you could use the same mechanism for behaviors. If you detect a behavior that can also kind of bias what objects you're expecting to see.
Yeah, I'm thinking about that. Yeah, maybe.
Yeah, I was just wondering if we would pass up the behavior ID, but I guess.
That's an
we
interesting
also would
question.
do that.
Right, when we talk about compositional behaviors. As a whole field, we haven't really dealt with is hierarchy, where there's no fixed relationship between the child and the parent objects. Like, you know, I want to do some behavior and I can do it in various ways using different parts of my body and different things. You know, there's not like a clear, from a behavior point of view, it's not like you do this and then this breaks down to this, breaks down to this. It could branch off in different places. And my point is, we have to deal with hierarchy in general in a bigger context of behaviors that we haven't really thought about.
So that voting between layers, is that voting or associative connections
Here,
between layer 3 and layer 3 in two different regions, like hierarchy?
they're right here, this idea that
Yes,
the
yeah.
child to the parent.
Yeah.
That's the same voting mechanism we've had elsewhere. It's just SDR to SDR.
They don't even need to know that they're in different hierarchical layers. And
Okay, but is there a difference between this and just associative connections between the SDRs? Or is it the same thing?
That is, it is associative connections with the way it works, it has to be associated between the two different regions and also associated within the parent, within each column, like.
Yeah, the cells, the mini columns themselves, or
Not the mini columns,
the unique representation is.
It's just like, yeah, you want to lock into something, right? You don't want to just say, oh, here's an SDR. It's more like, no, we want to settle on this one or this one. It's either a cat and a dog, it can't be a cat dog. Right, so pick one.
Yeah.
You know, it's a vase or a face, not a face vase, you know, pick one. So that has to have that locking in effect, which also has to occur within a column. So, but that's pretty simple. Basically, all the cells just make associative connections to other cells nearby, other cells far away. It doesn't make a difference. well, a little bit off topic here. One time I was thinking about the voting and I said, oh, we're voting over all these columns, right? And so you think that might require huge numbers of connections between these columns. And let's say I have like 5,000 cells in column A and I'm trying to vote with, thousands of other columns. It turns out that any particular cell, you take any particular cell in column A, it can associate a link literally to some sampling of cells in all the other columns. It doesn't have to go all columns. This has to be some subsampling and we just pick random and another cell just connects to some other subsample of all these other columns. So any particular cell doesn't have to connect to even half the columns out there or even, but if you do that, it all works. It still works. They still all settle. So you don't have to have these massive connections. I don't even have a name for that.
Yeah, the propagation between all of them at the same time is just going to keep
Right,
settling.
it's just
and
gonna
going
settle
towards
regardless.
one.
So this gets to the point, a cell doesn't know if it's connecting something nearby or far away or other columns, it really doesn't know. It doesn't know anything. It says, I'm just trying to associate my patterns with somebody else out there and they don't have to be coming all. It used to be like, oh, I have two cell populations, like this cell would have to connect to at least 20 of these cells. But really it just has to connect to 20 of cells anywhere that representing the same thing. Okay, off topic, but I think where we're going with this, we got down this path because we were talking about like in the notes of the melody that a child object would be the only thing that knows that it's a saxophone. A saxophone may vote on the song because maybe the saxophone's associated with particular, Bo Diddley or whatever, I don't know, some song. But maybe not. So if I'm hearing the song with a dog barking, I wouldn't have any association with dog bark with the melody. So that wouldn't work. But it doesn't matter because what happens is the child object recognizes the dog bark. It basically says, it has this, note here. We're calling it an orientation. I don't know what it means in songs, but something happened here, a change occurred. The parent object doesn't know what it was, but the parent object basically, there's an assumption somewhere in the system that it's continuing to be the same thing unless someone said otherwise. And I don't know. That's an interesting question. If halfway through the song it goes from dogs to violins, who's storing that transition? I think that transition somehow would be stored in the parent object.
It
But-
would be in the behavior model
Oh,
of the parent object.
But somehow it has to tell the child object, you should do something different now.
Yeah,
Oh, it would, it would, right, it would. It would basically say, oh, at this point, you said violin, and at another point you said bark, so it would just naturally, whatever, the parent object doesn't, the parent object actually doesn't know. The parent object just says, I'm going through the melody and, oh, wait, I don't know, it has to. Oh, yeah, and then at this point in the melody, you're associated with something, and at that point in the melody, it could be associated with violin, or at that point in the melody, it could be associated with a dog. I don't even know if the parent object even needs to know the voice change. Does it? I don't think it does.
what?
Um,
Who else would know that?
It's in the backwards, it would make the correct prediction because the parent object says at this location, I heard a dog voice, and another location, I heard a saxophone. And you learn that association. So,
Yeah, what there's stored in the layer 6 backward projection.
right, it's
But,
just.
okay, I
it's
was
just
thinking
an
that's
association
part
that-
of the model.
It's not actually part of the model. That would be an implication of this. It's not actually part of the model of the cup or the model of the song that that's interesting. So the equivalent on the stapler, imagine I have the logo of Pete's and coffee cup, the Starbucks, whatever. And the model of the stapler doesn't know, well, it would have the voting connection, but it doesn't know at this location it doesn't know what location there's a logo. It just knows that at this location, the child object isn't told the child object knows there should be a logo. The parent object doesn't know that. And this also means that if the if the logo changed from Pete's to Starbucks, the parent object wouldn't know that. The two know it. Because the two together, the stapler says, oh, at this location, you should see something, and then, and so at this location, here I am, and the child object will go, oh, at that location, I have the Starbucks logo, at that location, I have the Pete's logo. But the cup wouldn't know that. The cup would have no knowledge of that. Is that what that implies?
Would it lay down, so the feedback connections from layer 6 to the logo in the child model, would that be the reference frame of the static model then, or of the
Say it
behavior
again.
model?
Say it again.
Um,
I just didn't hear the words.
so the backward projection from layer 6 telling the lower level
Oh,
module which logo to expect at what point in time, would that be coming from the reference frame?
I don't know, that's a good question.
Static.
Now we have the option of sending back both reference frames.
Yeah.
Wow. Well, I would suggest this might be the clue to our hierarchical behaviors. Because you could have hierarchy of behaviors and hierarchy of models.
Yeah.
And so if I pass back the specific location in a behavior, that could invoke a child behavior right? This would be like,
Yeah.
I am, right, I need an example, but that essentially hierarchical nested behaviors could work the same way as hierarchical nested objects, is that a parent behavior wouldn't know the details of a particular point in the sequence of behaviors, but the child would.
Yeah, so then in the case of the logo changing, that seems like a behavior, right? So would the lower level module learn the behavior of the logo transition, and then the high level module would just tell the child to expect that logo change behavior now?
What if, okay, really weird here. I have a Starbucks logo. And as the stapler is opening, the Starbucks logo changes. It changes from green to red, or the little lady's hair goes up or something. At some point in the sequence that occurs. And I'm trying to make up examples, I don't know. I think the idea that you might pass back I'm trying to come up with examples where the behavior, there's a hierarchical behavior, like there's a change in the stapler, which is a change in the sub-object, but the stapler doesn't know the change in the sub-object. It's like, I think that needs further enumeration, but we now have the ability to say, we can vote on behaviors, we can vote on objects, we can pass down unique location behaviors, we can pass back unique locations and objects.
Yeah.
What do we want to do about that? You know? More tools in the toolkit here. That's a good idea, though. I mean, why not? It seems like it's a useful thing to do at some point.
Yeah, I mean, yeah. it
Where
seems
where am I in this
necessary.
behavior would tell the child object where it should be in its behavior, or something like that.
Yeah.
Or start a behavior, or I don't know, something like that. All right, I think
Maybe kind of like the traffic light might encode the global behavior of the sequence of which lights turn on and off, and then the child object would encode the actual feature change of each of the lights, like turning from like a dark green to a bright green, or
well,
maybe that
maybe,
would be an
although I
example.
think the change there is the same. If I represent color in the parent, I could do that, couldn't I?
I could, but maybe it would be more useful to abstract it away, to have the general sequence of a traffic light behavior encoded separately from how exactly the traffic light looks. If it's
Right, I was
actually
thinking
a
like,
round-
oh, I sometimes see, I know certain traffic lights, so that most of them have moved to LED, but not all of them. I can tell the difference, and when the ones that are LED, some of them have broken bulbs in them. And so you see like broken little patterns in the, So like, that's a specific one I know, like, oh, where I turn near my house, it's always missing these little dots there or something.
Yeah.
Something like that, maybe you're thinking.
Yeah, just, yeah, to have like a more general representation of that red, orange, green sequence versus the actual change in color and brightness happening on each location of the lights.
So,
Like you might also have the lights at slightly different locations relative to each
Right,
other,
right,
different distances.
so, do we want to summarize what we think we just learned this morning? So I try to write that on the board.
Yeah.
All right, I'll try to write it on the board. Um, So what did we decided that, that when it comes to behavioral models, we often need, often need two levels of hierarchy at minimum. Often, I'm not saying always.
Yeah.
No? I'm starting off wrong. What would you do first?
Okay, that wasn't my main takeaway from this one, but
I haven't organized my thoughts yet, so I'm just making a
Okay,
list of
yeah.
things.
okay,
Because I was thinking the problem that I was dealing with is how do I know constancy of a feature? Or how do I project that this is gonna be the same? And so we're gonna use a child object to make
Okay,
it constancy.
okay, yeah,
All right. Object is needed to essentially predict constancy of features, predict I don't have better words for it. So constancy of features. Like it's still black or it's. Maybe you have better ways of writing this. If you do, say so. The child object can also be a.
I thought, no.
Okay, go ahead. What are you gonna say?
I thought the whole child-parent hierarchy discussion was solving the problem of when the lower level feature, like the saxophone, is actually like a temporal thing
Yeah, okay,
itself.
that was the next.
But I didn't think it actually solved the constancy problem.
Well, because it does, because the parent object doesn't know what the feature is. Right, the parent object doesn't know, it doesn't know there's a saxophone, and now you should hear a saxophone, and it doesn't know, in the case of the stapler, I think it wouldn't, I would say it knows it's continuing to be black, or I might even go to say that, the child object, it doesn't know what the subcomponent is supposed to look like in its new oriented form. But this was the saxophone problem. The child object itself
So-
has its own sequences that the features are sequences themselves that need to be
So-
played back.
If the feature is something less temporally complex, something like just a color or an edge, would you
Anything that-
say you still need
No,
hierarchy?
no, I think only for,
Okay, so then I would say those are two separate problems. But
okay, you want to take it, why don't you take a step right? No, really, I'm happy. I'm not saying that, like, okay, you do it. It's like, maybe it's helpful, you could do it. I'm struggling to, I'm writing down a bunch of things we just thought about, and then I'm gonna organize them later.
Okay, yeah, no, go ahead first.
I also assume that the behavior model doesn't know what the feature is, so it can apply.
Right.
So maybe it's not a
How
hard.
about that? Because parent behavioral model, parent models in general doesn't know the feature, doesn't know a specific feature. It just doesn't know the feature. It's being voted with the feature, but it doesn't know the feature. No features feature IDs.
Isn't that also true for a behavioral model in the same column? Does it need to know the features? We're
I'm
abstracting.
saying, in general, a parent object cannot know the feature ID of a child object that's projecting to it. Just, it does not, voting is not the same as knowing it, right? It's not stored, the parent object doesn't know it. They're connected via the back projections.
Right.
But nowhere in the model of the stapler, or then the mug, do I actually store logo. And nowhere in the model of the melody do I store saxophone. And in the stapler, I'm trying to come up with something. If there was an ID like the coffee logo, there's nowhere is that coffee logo stored in the model of the stapler.
So is it a requirement to have two hierarchical levels to apply a behavior to a new object?
No,
Oh,
we didn't
it
go there
doesn't say
yet.
that.
We didn't do that yet. I didn't say that. Is that required?
Feels to me that this is trying to solve the problem of applying a behavior to a new
No,
object.
I thought we had a solution to that within one column.
So how I understood it was the hierarchical problem is independent of the behavior problem. We just started talking about hierarchy because we started talking about objects that are made up out of complex sub-objects. So we started talking about compositional objects where we have
Right.
the saxophone, which is itself its own little temporal
Right, but-
object. But I don't think there's a requirement to learn behaviors to have two hierarchical columns. If you
No, I
just have.
know, right. When I was writing this, I said it's not always required. I didn't write it down.
Okay,
So
yeah,
one high level thing for me is that in a parent-child relationship, we never pass up, the parent doesn't know the idea of the child. That was like a new idea today. It wasn't related to behaviors, but it's a
Yeah.
new idea today. So parents don't know the idea, and that's different than I was thinking about it. I was thinking about it that somehow that unique ID was being memorized, but not really. It's just being associated, so not the same.
yeah, so.
That was a big idea.
Separate from object behaviors.
Right, it's just a big idea in general, this is a new idea.
Yeah, for
Okay.
sure.
Okay, so it helps with our object behaviors. And then in behaviors, if there are two things you can represent, sort of base things that can be observed, like edges and colors and things that can be represented in a set of many columns, those, we don't need any extra help. But if the behavior is something that's an object itself, like a logo or a saxophone note, then that requires a hierarchy.
Yeah, but that's basically saying if we need to model compositional objects, or if we need to model compositional behaviors, we need hierarchy. But we don't need hierarchy for behaviors themselves.
I didn't say these are behaviors. I just said, if I want to make a prediction based on a behavior, I might need a hierarchy. If I want to predict a particular logo,
Yeah, if you have a compositional object, you need hierarchy. But if you just want to predict a color, you
right,
don't need hierarchy.
right. Right. I wasn't, I'm trying to make a list here that sort of incorporates behavior, it wasn't specific about behavior. I'm just,
Okay.
there's a, okay, so in my mind, this idea that the sub-object idea is not stored is related to behaviors, because we were struggling with like a saxophone versus color versus, trying to represent a saxophone note with an SDR, as Niels was suggesting. We're bouncing around ideas about that. And so I'm trying to just state what we concluded about that. Maybe I'll take a different approach here.
Yeah, in my mind, that discussion was separate from behaviors. It was
Okay.
about compositional.
Right, but it's gonna play
models.
out, we got there by thinking about behaviors, so.
Yeah,
It's important to know for behaviors.
Okay,
All right,
yeah, I
I
just
shouldn't
wanna,
have wrote behavior models, I just should have just,
yeah,
things we learned. A child object ID, just in general, is only used for voting.
Yeah.
Used for voting. That's a new idea, we didn't really have that before, maybe we thought of it, I don't know.
and that can happen
Independent of,
between hierarchical levels and between actual different objects, like
Right,
the child object can vote on the parent object ID.
right. Also, I used to think like there is, you know, there's a sound of a ceramic something hitting the table, and I recognize that. That could apply to lots of different objects.
Yeah,
So they're voting, they're just voting, right?
Yeah.
This sound could apply to these objects, this object could lead to different sounds, and then they vote together. So is that okay to start with this one?
Yeah.
Okay, I wanted to state something I'm gonna state as a conclusion, just to make sure that, I don't, Neil's gonna think otherwise, but I'm gonna say, I wanted to say something about mini-comps. You know, mini-comps can only represent things that are easily enumerated and observed. Do I need to say that? I don't know. What would be your next point on here?
Only parent objects can make predictions about the child object ID through the backward connection.
Okay, so, right, so this is, child object only used for voting.
Yeah, it's not a new thing, I
Right,
guess, it's just.
Right,
another
and then this
implementation.
is the back projection.
Can still,
Is the only way to connect. With certain, a parent and child relationship, you know, that this child is actually on this object. That's
yeah,
the only place that's actually recorded. There's no forward thing like that. Okay, and then we're gonna say, in behavioral sequences, how about this? In behavioral sequences, sometimes the change is in a child object with its own
behavior model.
behavior, its own, behavior model, time-based, right?
Yeah, so basically, you can compose object behaviors the same way you can compose object models. Like, we would use the same mechanism to have a child behavior as we would use to have a child object.
Yeah, you're essentially, well, what you'd actually be doing, your backward projection could be viewed as following. At this moment in time, you are observing an object in some behavioral state. And I'm going to invoke that object in that behavioral state. Right, imagine layer 6A, there was the two grid cell locations back.
Yeah,
And you're basically associating, you know, the current parent state with whatever object and whatever behavioral state of that object at that point in time.
yeah,
So it could be like, oh, it's supposed to be associated with, at this point in the melody, it's a saxophone, and therefore it starts like this and progresses like that. I'm at the beginning of the saxophone thing. Something like that.
can you start a child sequence, like mid-sequence?
I was thinking about that, and, well, imagine, the logo, and the logo is changing as I raise the thing, so there's a sequence of changes to the logo. Maybe this is an animated logo, the Starbucks lady goes, okay? So as you raise the thing, she goes, hi, and so if I stop the stapler halfway, I would say I'm halfway through the sequence and she's halfway through her sequence. So if I had a chance to say, I'm hearing the sequence in the stapler, it could be associated with both Starbucks logo and where she is in her sequence. Something like that. And I can stop anywhere, even places I haven't stopped before. Somehow I'm gonna be able to figure this out. I'm gonna figure out where her hand should be in that behavior.
Yeah.
So there's an example.
I guess what would be required to be able to do that? Because you'd have to kind of replay part of the sequence.
We haven't yet actually solved the problem of how do we know what something's gonna look like in the middle of a sequence if we never actually saw it,
Yes,
right? If I'm right about that during the sweep of the logo, a sweep of the stapler, there was no morphology model learning, only behavioral model. How do we know, how are we able to predict what it will look like if I did stop? Somehow we can do that. We haven't solved that problem yet.
yeah.
If a behavioral sequence sometimes change, in behavioral sequence, sometimes the change is, the change is in the child of its own behavioral model. So this could be like saxophone. No. Type of thing. Okay.
Can we also talk about feature consistency and
Well, maybe that's the part we haven't really completely addressed yet.
Yeah,
I would say like, we have a guess. I don't think it's a complete answer yet because we haven't really dealt with it completely yet. A guess, part of the solution is that a child object replays same behavioral object sequence, object plus same object behavior. Sorry, my writing's terrible. As it just, as recently, this as before, as recently done without any instruction otherwise. So
that would imply that we do need hierarchy for object, like.
no,
feature
it doesn't. It
constancy.
just means like, all it means is that I assume I do the same thing. I could just use the hysteresis. It could be just saying like, okay, I heard a saxophone and we're in a melody. And it says, I get back to him, play the same.
Yeah, I feel like now we get back to the problem where now we're treating object ID differently than features. But we want to have the same mechanism to deal with constancy, like the color of the stapler doesn't change, but
Yeah.
also the logo on the stapler doesn't change.
Yeah, I think the color is easy again.
in my mind, this is like taking the behavior of the stapler, applying it to a new object and making sure that the new object features is consistent and it does not change. Like it's taking,
Slow it again, say it again.
taking a behavior, some behavior of like the stapler opening and closing, the hinge behavior, applying it to a novel object that we haven't seen and making sure that the features of that new object is consistent over time.
But how do we make sure of that?
Well, I'm not suggesting a solution. I'm saying it's the same problem.
Oh, yeah,
It's the same problem of applying behavior to new objects.
yeah, I would agree with that.
And we never said that it would require a hierarchy to solve it.
Yeah, I would also say we shouldn't require hierarchy. It just seems now that we don't have the child object ID in a mini column anymore. We can't use the same mechanism anymore.
Well, the parent can't tell the child you're supposed to be hearing a saxophone. Right? You can't tell the child that. So the child itself has to say, I'm assuming it's a saxophone until I've learned otherwise. Right?
Yeah, and how about color? If we just have one hierarchy.
I don't need hierarchy for color, just like I
Yeah.
don't need hierarchy for
But then
edges.
there, the constancy is in layer 4 features.
Right. Well, I
versus-
think you could, both of the parent-child columns could work in the same way in terms of this somehow. They could
Yeah,
both
okay.
assume constancy until told otherwise. Let me just talk out loud slowly, so maybe I can get some ideas correct, I don't know. Imagine I'm a child object and I am now we're learning a song and I hear it being played with a saxophone. And halfway through the song, the saxophone changes to a oboe, whatever. I'd be hearing saxophone, 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 then I'm hearing oboe, 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 oboe. I don't know about the sequence. I don't know about I haven't learned the sequence of those. My sequences are saxophone sound, saxophone sound, saxophone sound, oboe sound, oboe sound, oboe sound. The parent object is basically going through a melody and it says, okay, at this point, you know, we're associating, these were saxophone notes and these are oboe notes. So, and that's the backwards projection. So, and when we play the sequence again in the future, the lower level doesn't know about the sequence, but it would say, oh, I'm supposed to play saxophone note, saxophone note, saxophone note. Now I'm supposed to play an oboe note, oboe note, oboe note. So I've memorized that song that way. Okay. And if I now hear the song with the dog barking, the backwards projection wouldn't predict I should be hearing a dog, right? It
You
doesn't know
predict a change.
that. It just says you should start another note now.
Yeah.
And so my lower column would say, okay, what should I do? One thing we could do is just say, oh yeah, I'll just keep barking. You know, it's like, that's what I did. I'm just keep barking. There's no other instruction otherwise.
But wouldn't it tell the lower column that something will change?
Would it? That's interesting because I can't predict the change. What's the equivalent of a change from a saxophone to an oboe, from a dog to a what, a cat? I mean, it doesn't.
Yeah,
mean-
you wouldn't be able to predict what feature to see next, but seems like the behavior model would say that there will be a change.
Well, you know what I might imagine, if I imagine listening to this, right? I've learned this beautiful melody and it's, you know, Beethoven something or other, and it's got saxophone, he didn't have saxophones, but anyway, violin, 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 oboe, oboe, oboe. And it's alternating back and forth between, and now I'm hearing the dog, you know, okay, the dog is singing this song, all right? That's not Beethoven, but it's Beethoven's melody. At the point where the transition would occur from violin to oboe, I might say, oh, is there gonna be an oboe next? Right? I mean, that's the only thing I could predict. I would think that. I would literally think in my head, oh, is the next note gonna be an oboe? Because, you know, that's what normally occurs here. I wouldn't say the next note's gonna be the oboe-ness of a dog. I mean, I wouldn't predict a cat sound. The only prediction I could have would be it's either, you know, it would be about an oboe. And if I start hearing it, if the dog continues barking, okay, the dog continues barking. So I think that just shows that the melody would predict an oboe at that point, even though I've been hearing dogs. But at that point, I'm not going to predict an oboe every song. Somehow the constancy of dog barks is going to continue, right? I'm going to keep expecting a dog bark.
This is carrying over the same behavior to the second part of where we change a feature. It's like, it's going to continue to predict with that new feature using that same behavior. I don't see where the hierarchy comes in here.
I'm just saying, I have to have a hierarchy because the thing I'm predicting is an SDR. It's a complex thing. I can't represent it in the single. I have no representation of saxophone or cat or dog or oboe in the parent object. So I need a hierarchy to play out that subsequence. That's why I need a hierarchy. And I'm just walking through the consequences. If the rule was, okay, I've learned this melody using one instrument, I would now predict that instrument. But I didn't get that instrument. I got a dog barking, but that's good enough because I can still hear I'm still recognizing it. And yet, until I'm expecting a change, I'm just going to keep going with dog. And when I expect a change, I'll think about what I learned before. But I'm not. That's all I can do. I can go from dog to oboe, but I can't.
Yeah, what I would say is the change from violin to oboe, while it's the first instrument, you're not actually encoding anything in the behavior model because nothing is changing. It's constantly that
No,
instrument.
every note. No, the behavioral.
The notes are changing in the high level, but
The behavioral model does not include anything about the voice. It's just the melody. There is no.
the behavior model in the parent column models the melody, but in the child
lower
column.
child doesn't know anything about the melody.
Yeah, exactly. It just knows that it's constantly the same
No,
instrument.
it's
and
not
it
even that.
changes.
It's not even that. It's saying, I have a sequence here's a pattern I recognize, an object I recognize. I've now got that object. And then, someone's telling me to do it again. What am I supposed to do? I don't know. I can't, it's either it's gonna tell me it's a saxophone or, you know, but I'm here, it's like, I'm gonna continue doing the thing I did because I'm just using
The lower
history.
level column that recognizes whether it's a violin or an oboe, couldn't that column learn a behavior model, which is basically just changing from violin to oboe?
It
Just
could,
that change
could.
and that behavioral
But
model is invoked?
when would it do that? Under what time frame? Would it be like this long period of time and then all of a sudden it changes?
No, it would only encode the change. It wouldn't encode
But
everything
when would that change occur?
when the instrument changes.
But it doesn't, it's gotta, if I wanna learn a behavioral model, like I'm listening to saxophone, 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 saxophone. I don't know anything about melodies.
Yeah.
And now I hear violin, violin, violin. Okay, there's a transition. When would I predict that transition to occur? I have no idea when to predict. It's not really.
Yeah, that's what the parent
Right,
object would
but
do.
I can't really learn that as a behavioral model because I don't know where it begins. It just randomly happened. It's like I don't have enough data to say, I can't predict when it would happen. It just happened. All I know is that I don't know anything about the melody. All I know is I've been hearing a saxophone, saxophone, saxophone. Now I hear dog, dog, dog. It's like, okay.
Couldn't the parent object tell the child object to expect that behavior?
It can, but
at
it
this
won't,
point in the
it can
sequence?
tell it, but all it's telling is like, right now, you should be doing this. But it can't, there's no knowledge about the timing of it, or where you are in the sequence, anything like that.
But the parent object knows where.
Right,
we
but the
are.
child object doesn't know that, so the child object can't learn it.
But the child object can learn the behavior of switching from saxophone to violin, which is just one-time change.
Okay, when does that
Before-
occur? If I'm gonna learn it as a behavior, I have to have a sequence of, like, I have to say, starting now, this is when it occurs. Otherwise, it seems random.
Yeah, so it's a very short behavior.
But
At the time when we keep hearing saxophone, we're not laying any points down in the behavior model because there are no changes
So
happening.
so that behavior model of the child can't predict anything. Because it seems like I'm going along and I got saxophone, 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 and then some random point in time, it changes the oboe. Well,
Yeah,
I can't
yeah.
predict that.
Yeah, the child object can, but
No,
the
but
parent.
when would I predict it? When would I say it's supposed to change? It's like random. It's like,
Wouldn't the parent object be able to invoke that behavior in the child?
right, but it's just, it's telling the child you should be doing oboe now, but the child itself doesn't have any knowledge about why.
Yeah, it's fine,
Well,
right?
no, but so the child can't learn it as a behavior. You're saying the child's gonna learn chance of act.
It doesn't learn when that behavior happens
But if you
in the
can't,
melody.
you
It
can't,
it just knows.
if it's not a repeatable pattern under some circumstances, there's nothing to learn. It'd be totally random from the child object's point of view. It doesn't know what melody it's in. It doesn't know anything. So it's just like, okay, if every day I knew a song began and 3 seconds into it, I switched, I could learn that. But it doesn't know that. It's just like, object, object, objects, new object, new object, new object. When would I predict that change? I can't, it's not an actionable model if I can't
I
predict
don't
anything.
think we need to predict it. I think this is coming from.
But
so-
what, a model is about prediction. If I
No,
can't,
no, but so the model learns the behavior, but then if midway through I started hearing violin, so this is coming from the sensory input. Then the model knows how to apply that behavior.
which
to
model?
continue. The
The parent's model.
The child.
The
No.
parent model knows it, but the child doesn't. The parent, here's what the parent knows. Actually, the parent doesn't know anything what's going on in the child, other than the voting signal. But it's this thing, I'm going through the sequence, I actually don't know, because we've said, we're not passing up the unique idea of that child. So the parent's going, I'm going through this melody, blah, 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 blah. And then the child is associated, hey, I just heard a saxophone and I'm associating with that parent SDR. I heard another saxophone, I'm associating with that parent SDR. I heard dog, I'm associating with that parent SDR. So when the parent goes through its melody again, it'll tell the child like saxophone, 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 dog, dog, dog. But there isn't enough information in there for the child to learn that behavior. It will observe the transition, but it has no idea when it occurred or why it occurred. It seems to be random to it. It's just a random
To me, the
change.
child can apply that behavior to a new feature, which is the violin, the change from the saxophone to violin, but it doesn't need to learn that there's a feature change that's happening here.
Well, you could argue that it's seen that transition, but it's not a very useful model if that transition occurs rarely and randomly. If every other note was a saxophone and a dog, or something like that, then you could say, oh yeah, I'm gonna go A, B, A, B, A, B, maybe that's the pattern I learned. Otherwise, it will just look some random in time, rando change that I don't know why. I can learn it, but it's not, I can't really make a prediction about it. I don't know when it's gonna occur.
The idea here is feature consistency, right? We want to keep the same
Well,
behavior.
we're
apart
trying to
from one.
solve, not just, we're trying to solve a set of problems of consistency being one of them, right?
It's like, well, if you have a stapler and we open it, and then but halfway it changes to pink. We are able to know that if it changes to pink, I can predict that it's gonna continue pink.
But we haven't done the constancy part yet, but that's part of this.
Yes.
But that would be easy. I observed this the first time, right? I observed this, and I see it goes from black to pink. The model learns that, right? Just like here, it learns that. In fact, it could be learned in the parent object, doesn't even need a child object. There is no sequence of black to pink. It's just at this point it's black and at this point it's pink. So that's that. So where are we going with that one? I'm not sure where we're going with that one.
I'm just saying that the behavior can be applied to a different feature. I'm
Well,
not talking about the
so
prediction here.
let's just talk about now. So now I see a green stapler. What should it change color to halfway? Do I expect it to change color halfway?
No,
Why not?
I think
because
that
we're
you
applying
would
a behavior,
expect-
abstracting that away from the features. I don't care what the feature is. If I see it green, I'm going to say it's
The
gonna
model of the
continue.
stapler is black, black, pink, pink, pink. Now I see green, but I recognize it's the same sequence. Halfway through this, I might expect it to turn pink. I'm not expecting to turn any other color. I might think like, oh, it could, I don't know, it could stay green, but if anything, I expect, the only expectation I possibly could have about a change, which is turning pink. This is like saying, the same thing. I'm going through, it's dog, 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 and now it's violin, 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 right? If I know where I am in the sequence, I make a specific prediction, but that's coming from the parent. If I'm just a child object, I'm hearing dog, 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 I have no expectation that it's gonna turn into violin right now, none. I have no, how would I know?
So is a transition between saxophone and violin, is that in the behavior model?
It's in the parent behavioral model. It's not even that, it's not even there, it's just that the parent behavioral model has a set of states, and I associate some with black and some with pink. Well, actually, the color one, we should separate, we should, because I think color can be handled in a single, color is not a child object. So there are things that can be handled in the parent, and anytime I have a child component that requires an ID, it has to be handled in the child. If it's something I can handle in the parent, like edges and color, I don't have to do that. I can do it all up above. However, if it was a logo on the stapler that changes color or changed somehow, then it require a child object to do that, right? Because it's not just color, it's an object. I think this all works, but I don't think you're convinced. I don't think Vivian's convinced.
Well, I'm okay.
Okay, I thought you were pushing back on this.
Yeah.
I still don't, I mean, the hypothesis right now, which is a little weird, is that if I'm a column and I'm observed the behavior and now it's like some location in some parent object, I don't know. And now I'm being told from the parent object, do behavior again, but I have nothing new to learn from. I haven't learned to associate that new location of the parent object. I'm just gonna play the old one again. If I haven't learned to transition and you're saying, okay, I got like a dog bark at some location, dog bark at some location, a dog bark at some location, dog bark at some location, dog bark at some location. And now it says, here's another location. At this time, I'm gonna do another dog bark, even if I've never learned that. Just gonna say, okay, without further instruction, I'll do the same thing. So it's like a hysteresis. I mean, I don't like this, but that's what this implies. And yet I could have learned, if I've been through the song before, I could have learned that on a unique SDR here, or any of these SDRs as I'm going through the melody, that I can associate the dog bark with the location, associate the dog bark, or associate this location with the violin, then I would predict violin because I've learned that. But until I've learned it, I have to just assume it's gonna be the same thing.
Yes.
So that's a little weird. I don't really like that. But that's, right, that's what it is. Somehow, we want to transition back to the stapler, where the stapler top is like the dog bark, okay? And if I don't know any other, if I haven't learned that the stapler top changes somehow, I'm just gonna assume that it's gonna be the same stapler top in some new orientation.
Yes.
Whereas before I was only, it's a dog bark, I assume that something, by the way, we have to, it's not just a dog bark, it's a dog bark with a particular note. So we didn't talk about that, but, so it's not just the stapler top, it's a stapler top at a different a specific orientation. So those are parallels there, that's a clue.
Yeah.
I was wondering if, could the notes be thought of as orientation? I don't know what that means.
Almost seems like it.
I know, but I don't know what it means. It's like it's fuzzy, right? You're like, oh, what does that mean? Can you have a clear picture of it? I don't know.
You don't get back to the first note if you go a full circle, but
No, I don't even know what it means, orientation for notes. I don't know. Yeah,
I guess.
okay.
Yeah.
I don't know. All right, so we've summarized here, the melody or the parent object actually doesn't, other than the voting, which we can ignore for now, it doesn't know anything about what's actually comprising, if there are actual individual feature IDs as part of this object, it doesn't know them. But it can associate its location with a particular ID at a particular node. The child object doesn't know anything about the behavior exhibited here, unless it somehow surfaces as very repeatable down here, right? Which could be. But the general rule would be no. But it could be, sometimes it could learn, sometimes it could say, yeah, I'm only looking at the child object. And as a child object, I can see this behavioral change. I can learn how this thing is changing over time. Other times I'm arguing like changing from cat to a dog voice to a saxophone. It's not gonna learn that. Okay, and then since the analogy is between the dog bark is like stapler top. Something like that. And the stapler, somehow yeah, I don't know, something like that.
So for the color constancy, you would use the same mechanism, I guess, just.
I think
in
color
different
constancy can be handled
layers.
in the parent column. I don't think I need anything else.
Oh, yeah, I would definitely argue you don't need hierarchy for it.
Yeah,
Just like, it would be the same thing that we would, if there's no change in the behavior model, we would expect the same feature to be
right.
invoked in layer 4.
Well, yeah, and I don't know how that, I don't know why, but you can just imagine it, I guess.
And the same location in layer 6.
I don't know.
I don't know.
All I could do is say the colors. I assume that I wouldn't really learn anything until it changes. I wouldn't learn, why would I learn anything new? I don't want to learn that it's still black, 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 black as I'm moving some space.
Oh, you wouldn't learn it, you would just expect it.
Right, right. Even though the location is changing. The color isn't changing.
Yeah.
So one could argue, I could learn the color of the new location, the color of the new location, the color of the new location. Or one could argue like, oh, well, for all those locations, I'm just gonna be black.
Yeah, I think that's what you'd have to do, because you can see a stapler in a new color that you've never seen before, and you can predict it to stay the same color, even
Right.
though you never learned that association of the
Right,
new color
right,
with
right.
locations.
Um,
So you just kind of have this, prior, like, what do you call it? Implicit knowledge that it stays the same if there's no change in code.
it's implicit in the sense that nobody knows this. It just says, until I hear a change that I'm
Yeah,
gonna be the same. You could think of it like the following. Imagine you've got these two, you got the two models. This is like 4 and 3, let's say, like 4 and 3. And I have these shared mini columns. So the mini columns have the same definition on the behavioral model and the object model. And it's sort of like, if I don't have any change up here, I don't force a new change here, I'm just gonna keep the same mini column. Like, it's the same color, it's the same edge, I don't know, it's the same feature, the feature hasn't changed. But if I get a change up here, if the actual encoding of features changes, then it forces these guys into the new set down here. So this is the, this layer has temporal persistence.
So how would it know which new columns to invoke in layer 4, given the change?
Because when a change occurs, it's like, it's changing color. The color appeared, the edge appeared, something appeared here that wasn't there before. That
Oh, that
evokes
was-
the entire column.
Yeah, okay. Okay,
And-
yeah, that makes sense, I think.
Right,
But
so,
and then for locations,
well, all right, so now, there's an interesting question. So basically, I'm saying, okay, nothing has changed, keep constancy here. As soon as something changes here, force us to be new. My location can be changing right now, right? The location, not in this space, but the location in this space.
yeah,
Well, I guess the location in this space could be changed via time, so I'm now at some future time point, so it's changing there too. But here I don't have time, so basically, if my center patch is sitting in, well, if my center patch is moving around and nothing has changed up here. So like I'm moving my eye across the stapler or something like that. And nothing's changed up here, then I'm gonna assume that all those locations that I'm looking at are gonna have the same pattern here. Whether I learn to associate this pattern with all those different locations is an interesting question. I might take some more synapses.
but yeah, that's a nice mechanism for the color constancy that, yeah, you can have the stapler moving, but still, since there's no color change encoded, you just keep the same mini column active in layer 4 for the color. I guess the remaining question is, if there's a movement change detected in layer 3, how is that getting translated to expected location change in layer 6? Like if you detect,
Well, I think it's a separate problem. That one's not a problem. If I'm observing the location, but if I'm observing the change, if I'm looking at the location where the change occurred, then by definition, I know where the change occurred. I'm looking, the problem here is, what if I'm not looking at the location where the change occurred?
yeah,
Then I have no idea that anything's supposed to change elsewhere.
yeah, so you have a model of a stapler opening. How do you know that if you saccade to a location on the stapler, new location of the stapler top, that it will be there
Right.
and not somewhere else?
That's the problem. That's the occlusion problem. Like, how do I know if I'm not tracking it continuously? There was two very related problems here. One, I expressed it as an occlusion, like, even if I can see the whole thing, it gets occluded. I can't really see what's supposed to come out the other end. And the other problem is, if I'm a single column, I can only observe one point in time, and I can observe the change at that point. But the other changes that are occurring, even if they're in the model, I don't observe them. I just. So imagine this. Imagine your behavior is this space-time slices. Right? Each of these is a two-dimensional sheet. Right? So I'm moving through time, and I have two-dimensional space. And on these surfaces here are where changes are occurring at that point in time.
Yeah.
And as a center patch, I can only move through here at one point. I can move here, I can move up to here, I can move down to here, and so on, but I can only observe that one little point. So I can observe, if I happen to be there when the change occurs, I go, oh, I know the change occurs. But what if a change occurred elsewhere I'm not observing? And now I go like here, change occurred here, and I'm not observing it at that point. The change occurred at this point in time, right here. I'm not looking at that. The model tells me it changed, but now I go up to that point. I need to be able to predict what's there, even though I wasn't. It's like, let's say it said, this change is green appeared. Okay, at this point, green appears. At this point here, I don't say that anymore because green's already there. It's not a change anymore. It appeared. I come up to that point now, I need to know it's green, even though I wasn't there when it changed. How do I know that it's green there? This is an expression of this problem in the general sense. How do I know that?
Isn't it with color? I feel like it works because if we are, this is assuming we've already learned the behavior model, right? So
Yes,
so the time sequence the time signal that we're getting in is already invoking the changes that we expect in the behavior model.
but I'm not observing this, so how do I know how to change? If I'm a patch, a sensory patch.
So, okay, so the sequence of changes invoked in layer 3, like basically we've learned the behavior, now we want to replay the behavior. It would only replay the locations that we're looking at any
The
point in time.
behavioral state of the column will go through it'll go through the entire behavioral state over time.
Yeah,
But I can't observe all of the spaces in that. I can observe every point in time, but I can't observe every part of the object at any point in time. I can only observe one part of the object. I'm only sensing one part, right?
but can the column represent?
The
Changes
column
at
can
the
only
first-
represent, at any point in time, it only represents one point, where the sensor patch is. I can make predictions about where I'm looking at that location. Unless I invoke another location, I won't know what is stored at that location. There's no way, the neurons don't become active until I'm at that location in time, in space and time. So even though it's in the model, in the connections, there's nothing dynamic happening here. It's in the connections saying, if I was at that location, I would see this change. But if I'm not at the location, I don't see anything. I mean, I see what's down here. I don't see what's up there. Even though the model, if I was looking there, the model said, oh yeah, you're supposed to be a change here. But I'm not there, I'm down here, and I wouldn't, how would I, it's like I have to it's like somehow I get to this point, I have to go back in time to find out where the last change was. You know, it's like, how else would I know?
Well, this would require all the columns to be voting on something like a global state ID. But then we can't do that.
Because all the columns,
So these patches, they need to be agreeing on the whole state of the object at the same time. Because the color
right
bottom is
now, I'm just talking about one patch.
Right.
Right, now, one patch has this problem, like I'm looking. Imagine I'm looking at something. And I've learned the behavior of this object, I have the entire behavioral model. And now I'm watching the stapler arm go up, but I'm looking down at the bottom, towards the bottom of the stapler. And while I'm doing that, the behavioral model says, oh, the top should turn green. Not the part I'm looking at, but the top up here should turn green. But I'm not attending to that. I'm looking here, and I'm not seeing that. And the part of the model that tells it turns green is not even invoked at this moment. So there's no dynamic representation of that. It's just in the model, but the model is not invoked. So now I zoom up, I'm looking down here, and now I go up to here. I should see green, and I should know I should see green, even though I wasn't attending to where the change occurred.
So, could we invoke, like, we have the mini columns and maybe one of them represents the change to green.
Yeah.
We
Green,
have-
it just green appears. Let's say green appears, right?
Yeah, green appears is what this column represents. And we have this temporal sequence coming in.
Yeah.
And it, maybe at first it predicts that red appears
At
at
the same
some
location,
point in
at the
time.
same location or different location?
All right, so we have the reference frame here. And this temporal sequence would predict red appears up here at some point in the sequence, and then it would, at a later point in the sequence, it would predict that green appears
Okay.
at this location,
Right,
like a traffic light.
right.
So, but we're not attending to this location when green actually appears. Let's say we're still looking at this light, we just saw it turn off. We didn't actually see this light turn on, but still, wouldn't this sequence here have still kind of invoked this, even
It
though
only
our sensor
invoked
wasn't
it in
here,
the
or like
sense that-
at least depolarized or
No,
somehow.
because
Yeah,
I have to pair it with the location. Like, I can't, imagine green appears here and orange appears here and purple appears here all at the same time,
Yeah,
right? That information's in the model, but it doesn't get invoked until I go to that location. Then I would say, oh, I'm at the location, it's supposed to turn green. Oh, I'm at the location right now, it's supposed to turn purple, it's supposed to orange. But if I'm not there,
but could this signal, like this temporal signal somehow say, oh, I am expecting a change at this location, even though currently my sensor is not at that location in the reference frame? Like, could it still kind of make,
well, it could invoke a union, I suppose. I mean, remember, there could be lots of changes, like I just suggested here, not just one change. Bunch of changes could happen at the same time. So for that to occur, I'd say that at this point in time, I'm gonna invoke the union of changes. So I'm predicting it changing purple, I'm predicting it changing green, I'm predicting it changing orange. But until I go to the specific location, I wouldn't know which one it is. It's just sort of saying, all these things are happening, but I can't invoke the specific, I'd have to be a union because I can't invoke them individually.
yeah, I
Um,
guess.
So is there another column that's looking at that change at the same time, or are we assuming?
Only if you said there's another column. At one point last week, I said, oh, this has got me thinking about lots of columns working together. And the reason I got there was because I was trying to imagine just learning the behavior of the stapler. And I'm saying, oh, it's gonna be really hard for a single column to do that.
Right.
Because it can't get to all those locations. We have the same problem here. A single column can't make predictions very well because it can't get to all the locations. If I had a whole bunch of columns that all had the same model, and they're all looking at different parts of the stapler, individually, those columns, somebody would observe every change, right? They'd say, oh yeah, I'm expecting this to turn purple over here, I'm expecting it green over here, and they'd all invoke that. But that still doesn't solve our problem, because if the column that was up here and said, oh, it turned green, another column said it turned orange, when the green columns go down here, how would it know? It's supposed to be orange. It doesn't know anymore. This guy doesn't, how would I know that? It's almost like you have to have some sort of ability to go back in time to find the last change and then bring it up forward or something like that. You know, I don't know how, I don't know the answer to this question, but that would be one possible answer. Like I get to some point and I'm looking at some point and I don't know what to expect. So I can just say, well, let's go back in time until to see the last thing that changed. The last thing that changed was this became green. Okay, it must be green because that's the last thing I saw.
But it kind of seems like this sequence signal must make some prediction, must activate something here, because often we predict a change and we kind of anticipate to look there before the change even happens. Or,
Well,
yeah, or we can directly move to that change that we expected in the behavioral sequence.
so imagine if I had only one change in my slice of time. And we're predicting that this part of the model is going to change. Well, I would have information. I could, in theory, say, okay, direct your attention to that one location.
Yeah.
And you should see it turn green. I do that with the traffic light.
Yeah.
I'm looking, I'm anticipating it's gonna turn green right here. I'm waiting for it, right? But if I have lots of changes occurring at once, like the edge of the stapler.
You can't attend to all of them, but
We can't,
you
right.
could still kind of make
But-
predictions
But
about
I
all of
can't
them.
make predictions about the ones I didn't attend to because I didn't know how they're changing. And
Yeah,
so-
if you've learned a model of the stapler.
But the model doesn't tell me, the model tells me when a change occurred, where it occurred, but it doesn't tell me that it's consistently there. Right, that's the part we're trying to have. I'm looking at some future time after the change occurred, how do I know? And it's already happened. It'd be like I'm looking for it's like I'm looking through a straw and I'm looking at the green light on the stoplight and I'm waiting for it to turn green. Right? How do I know that when I get up to the top, the red is no longer there? I do know it,
It's part of the behavior model.
but how do I know it? How am I?
There's another column that's looking at that part that you were looking at before.
Well, okay, we can try to use multiple columns to do this. I just gave an example where I didn't have multiple columns. I was looking through a straw.
Yeah, but that column has learned the entire behavior of the traffic light,
Right,
right?
but when it goes up there, there's no change there. The change occurred earlier in time.
Yeah,
So
so
how does it know? How does it know that
why
earlier?
couldn't the learned sequence in the behavior model make a prediction, make a prediction of how it's gonna change at a certain location, even though the sensor is not at that location right now?
But I can't make these predictions at all these locations at once through time and keep track of them. Right? How would I do that?
It seems like
I
it
can't-
must be happening, like,
Well, there, it is, what I'll say is, we are able to make the prediction that the red light's no longer red. I don't have a proposal how that works yet that I think works, that makes sense. I can't keep track of all the changes that occurred in this thing. If it's this, the problem may come about because I've said that the behavioral model is only based on like the appearance of a feature. Right? And so it goes away.
yeah.
If I said it turned red and then it goes away. If somehow I said it turns red and it stays red, well, then I can come back there and I know it's red. But that doesn't seem like it's a behavior model. That seems like a static thing. And even then, it's like, the behavior model has all these possible changes that are occurring at once in different locations. And, well, let me just propose an alternate. I just yesterday suggested that we think of the behavioral model as this thing, a feature appeared. And it's only representing change. What if the behavioral model didn't work that way? It's like as I'm going through time here. These are spaces at different time slices. And so in that space, I could say, I marked the beginning of this turned green. And what if I kept it persistent, saying it didn't turn green, but it is green, didn't turn green, but it is green, you know, somehow I could just persist that.
Don't we get that from the static model, that whatever's not encoded in the behavior model persists?
Yeah, but the problem is, if I'm not attending to that location, nobody knows it happened. The behavioral, the object model doesn't know. I wasn't looking at that location. How can I change anything? It's like, it's a part of the model that's hidden. All kinds of stuff could be happening throughout time, and I'm not observing it. Tons and tons of stuff in my model could reflect things that could happen, and I'm not observing it. Yet it seems like when I do observe it, at some point in time, I know what it is. Imagine your house. Imagine you have a house with 6 rooms in it, and every hour, someone rearranges the furniture in those rooms in a different way. 1 o'clock, it looks like one, and 2 o'clock, it looks like the other, 3 o'clock, like this. Your house has got different parts of it that are changing, and they change over time. And I'm in room A. I can see things that are changing in front of me, let's say, but I can't see any of those other things changing. And there's, until I think about those other rooms, there's no invocation of those other rooms. There's no instantiation of those other rooms. But it's more like okay, it's 3 o'clock. I'm thinking about the room now. I'm going, imagining being there, or I go there. And at 3 o'clock, I expect it to be in some configuration, even though maybe it was changed at 2. It's sort of like saying, yeah, it was changed at 2, but I know it hasn't changed again since then. So it should be in the configuration that I got at 2 o'clock. It's sort of like saying, I'm going over here, the change occurred back here. Somehow I have to propagate it forward, knowing that nothing has happened since 2 o'clock. Therefore, I now can imagine this, but I didn't actually observe it, that room at all. So nothing, it's only when I get to the room or think about the room at 3 or some other future time, then I realize, oh, what had happened up to that point? It's like, oh yeah, should have anything occurred? What should the state of it be? It's 2:30, last time it was changed as 2, there should be in this state.
Could it be
But
like
the change is actually occurring at 2:30, at 2.
could it be like a like a fast mental simulation of going
It
through
could be.
that sequence and paying attention to
Right,
where you wanna?
it could be like as much as saying, but it feels more like, go back to the last time I know a change occurred, mentally simulate the change. I don't go further back. I don't see what happened at noon or 11 a.m. or something like that. I just go back to the point where the last change occurred. And say, okay, when was the last change occurred? Oh, it changed to green. Okay, it's gotta be green. Yeah, I could do that. It's weird. It would be like you go to some point and then you have to go traverse back through time backwards.
But you could do it very fast, much faster than the behavior happens.
All right, I'm just trying to imagine the neural mechanism for doing that. Like back
Yeah, you
up time.
basically replay the behavioral sequence that comes from layer 1, quick, faster or same speed. And you would mentally pay attention to a certain location in that object's reference frame.
Well, you just by the fact that you're looking at it, you're observing it, is all you need to do.
And
It's a little weird. It's like saying, okay, let's go, let's imagine what the staple goes whoop, and doesn't stop in between. And now I'm saying, oh, it's gonna stop in between. What should it look like? So I can imagine, at any point in time, I can reverse in time until the last change. Well, the last change was really nearby, so that wouldn't be hard. It'd be more like, okay, halfway through the movement of the staple, the logo changes from Starbucks to Pete's. And now I'm I'm not observing that, but at 3/4 way through the movement, I say, what should I be observing? Look, Starbucks or Pete's. And I'm not observing the point where it changed. So I have to say, okay, in that location, let's go back in time to the last time it changed. What did it change to? Now I'm going to predict that. Ooh, that's a bit hairy.
yeah,
Related to this is the fact when you look at grid cells, they're always like playing sequences. Do you know this during the theta cycle? They're like on a point in like the grid cells represent a point in space, but they go actually on every cycle of the theta rhythm. They actually go through a sequence of points in space. It actually goes from further away to where you are to further back. It's like playing the trajectory of your movement over some short distance. And so it would actually, in theory, it would invoke experiences that you saw or expect to see very rapidly every theta cycle. Zip, 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 zip. You're not aware of it.
yeah.
And I have some speculations why it's doing this, but so in some sense, you have a little bit of window which you could go back in time and say, well, back in time, what would this thing occur? Right, but I may need to go very far back in time, right? I need to be able to say, oh, 2:30, what was the thing that, 2:30, what happened in this room? I'm just saying there's this mechanism of going back in time that exists already, but it's usually over very short periods of time.
Yeah, I mean, it seems like if you have to do it over long periods of time, you can't do it at a very high resolution. Like you wouldn't be able to like mentally simulate its complex long-term behavior.
Well, I don't know, I gave the rooms, the example, the rooms.
But it's just like 1 change per hour, so you can speed that up very fast and go through it very fast. But what if there were like people dancing in the room and they're,
Right,
current-
right, and they were doing a jig to a very rigid time frame. I know
Yeah.
that jig. But now I exit the room, I come back in, and even if I know the time, it'd be very difficult to predict
yeah,
where they are. Because there's been so many changes,
yeah,
and I haven't learned the intermediate state, so I have to go back to some, I don't know. Yeah. Yeah, that's possible. Yeah. Yeah, there's this research about rodents, when they're sleeping, that the hippocampus plays back, things that happened in their day. Like, plays them rapidly,
yeah,
but things over longer periods of time. So it's clear that the neurons, at least during sleep, are able to say, oh, let's go back and play it over again.
yeah.
By the way, in the case of the stapler, imagine I'm trying to predict what I'm gonna see. And the idea of maybe the logo changing halfway through means I might have to go back a fair amount of time to see when the logo changed. If I'm trying to predict where the edge of the logo is, well, I don't have to go back a teeny bit of time because the last change was just a moment before in a different location, but there's, well, if I'm looking at this thing here at some point and I said, when's the last change occurred? I'm only have to go back, oh, it changed, the edge appeared here. Or, well, the color would have to go all the way back in time, like, or I don't know. Right, it's a wonky mechanism.
Yeah, but, yeah, if you think through it, it seems like that's kind of what you're doing.
Is it?
If I think about the stapler changing the logo on it while it's occluded, I would kind of mentally simulate the logo changing while it's behind whatever it's including.
Well, let's look at the
including it.
lid of the stapler opening. And now it stops and I have my, I'm looking at some part of it. And I say, okay, what should I be seeing here right now? I have to like go back in time to like when things last changed. But now if I go, it stopped and now I go to another location, do I have to go back again? Another, or maybe not, because maybe we're gonna solve the top of the stapler. with
Yeah,
a
you have the
sub-op-
top of the stapler's rotation and
And
then
it's a
that gives you
sub-object.
all of the predictions.
Right, right. So we're really just predicting like morphology or.
What if there was
color.
another behavior that's changing to some part of the, what if there's like another behavior changing to some part of to a stapler? I wouldn't be able to learn that. Like I would have to split that again.
What, did you learn the stapler?
I learned the stapler and it's moving this way.
But we're saying, in that case, the solution there, we're gonna break out the whole top of the stapler as a sort of subcomponent, and so.
There could be another change happening here, and I'm not sure.
Right, but then I'd have multiple subcomponents, like the door idea of the top of the stapler. In all cases, I still have to back up a bit in time. I don't know, I have to back up in time to predict what's gonna happen. On a very abstract level, one can argue you have to back up in time because the behavior is complex. If the behavior is complex, then there is no other way of knowing the current state unless you play through the complex sequence of behaviors. It's like, the logo danced around a little square. And it goes, and now I'm gonna look at the logo, where is it? It's almost, I have to like go back in time and say, oh yeah, okay, it should be here. As opposed to just like, I don't know. It's weird.
It's easier with multiple columns.
But we can talk about multiple columns. It's easy, but it's also got its own set of issues, which I'd like to get to. If we want to attack that next after our break or whatever we're gonna do next. You want to talk about multiple columns? That's gonna be really hairy.
Yeah, when, do
Oh, what
you wanna
time
go
is
for lunch at some
What's
point?
our board meeting at 1?
Yeah,
What time is it now?
12.
Oh, maybe we don't have time to continue.
Yeah, maybe we should get
For lunch?
eat something at some point.
Okay,
and-
and then we'll have to leave the multi-column discussion to.
Yeah, and
Another
maybe
day?
it's a good stopping point now, I don't know,
Okay, right.
before we get into too
All
much
right, so
stuff.
where we left it is we got this weird idea that to make a prediction, we use with the behavior model only detecting when things change, when new things appear or disappear. That to make a correct prediction, we have to go back in for a particular location in time on a particular location of the object. You'll have to go back in time to the last time it changed and move forward to see what it is. Well, the last time it changed tells you what it is, because it changed to green, then you know it's green. How that would work, I have no idea. But we do know that there are mechanisms for grid cells to go back in time.
One other random thought I had earlier is evolutionarily, it seems like the behavior model is actually a lot more important than the morphology model. Like
Right.
if you imagine animals that have a motion-based vision system, it almost seems like they only have a behavior model. And that's enough for most things that you need to do to just see, like just recognizing behaviors.
One can argue, I agree with you, but I'm not sure it's more important, but it's definitely right up there. And many things you need to know are just behaviors.
Yeah,
It doesn't really matter, the current morphology. Right, I agree with you. I wouldn't say morphology doesn't matter.
no, it obviously matters because otherwise we wouldn't be able to model it,
It'd
but
be nice to see that there's a tiger there, even if it's not moving.
yeah, and especially like things where color matters, for example, it's important, but if you're just like a dinosaur catching flies or whatever, you just need to recognize that movement and go where that movement is happening.
Well, frogs, we know like there's a famous paper, what does the frog's eye tell the frog's brain? Have you read that?
No,
It's basically arguing that the frog's eye detects motion that are likely flies. It doesn't say anything else. It just says there's something moving in this trajectory and it's probably something you want to eat.
yeah, so that just has a behavioral
If the
model of
fly
a
stops
fly.
moving, the frog doesn't see it.
Yeah, so it in that case, it only needs the behavioral model.
Right.
And it doesn't actually need the morphology model in order to catch flies.
Just like fine tune to the behavior,
Right.
so like the trajectories of the fly.
Right,
not
it's
even just
very, it's a
velocities.
very, very simple, I mean, frogs don't have cortex, but you know, it's the same idea.
It's like a early Barlow paper.
The one I just mentioned?
Yeah.
I don't know who the author was. You can look up, that's literally the title, What the Frog's Eye Tell the Frog's Brain. I'm pretty sure that's the title of the paper. Really. You know the paper, and is that, you think that was?
Yeah, some of the early Barlow work on the fly like basically fly detector stuff in the frog, but I'm not sure if.
Did you find it? Oh, it goes back to McCulloch. McCulloch is like the super old guy, McCulloch and Pitts, do you remember
Yeah.
the?
So it would have been around the same era, so 41, so it says.
I don't remember the details of the paper, but that
That's
was
what you really-
the summary. The exciting aspect is that stimulus such as variations in everything else can cause little change in response. It's not light intensity, but rather the local pattern variation in intensity as an exciting factor. I thought it was about flies. They don't mention that there. Maybe I'm confounding two papers. There's this one, and then maybe there's another one that talks about flies. I thought this was the fly one, but there is a fly one. This isn't there.
No, it doesn't sound like it's only a motion-based system.
Yes, it
That's
doesn't do that
sharp-
here,
sharp
although
edges.
there is another paper that does, so I don't know, maybe
Yeah.
I'm confusing it.
Maybe, I'm not sure which animals actually have motion-based vision.
I don't know,
I only know it
but
from
there is
Jurassic Park.
paper, there are papers based on the fly that says it detects the fly, and that's all it cares about. I thought that was a paper, but apparently. Okay, anyway, that was your observation. I would agree with it. Behaviors are very, very important to recognize them. And even recognize them, like if you're seeing an animal in a modeled image of a trees and leaves, you know, you want to see that if the animal moves, you want to see the behavior of the animal pop out, right? Because it's moving, the behavior model recognizes it as a particular animal. If the animal's not moving, you don't see it. So it's really important. Okay, we can stop here.